nahi gyanin sadrasham pavitra mihi vidyate. There is nothing in this whole world as pure as knowledge. I, Dr. Swati Gangwar, on behalf of the Department of Mechanical Engineering NSUT, welcomes you all in this 2-week industrial training program on finite element analysis and its application using Ansys from 19th to 30th June 2023 in association with Ansys ARK Info Solution Private Limited. Before starting the program officially, welcome of guest as token of love has to given. In this respect, firstly, I would like to request Professor KPS Rana sir, Dean FEME, to give token of love to Professor PM Pandey sir, Chief Guest of this program, Director BIET Jhansi. Thank you, sir. Now I would request Professor D.K. Singh sir, Head Department of Mechanical Engineering, to give token of love to Dr. Tushar Sharma, Technical Manager in ARK Info Solution Private Limited, Industrial Export. Thank you, sir. Now I would request to Mr. Sanjay Gupta sir, Program Convener, to present token of love to Professor KPS Rana sir, Dean FEME. Thank you so much, sir. Now I would request Dr. Vivek Kumar, Program Coordinator, to present token of love to Professor D.K. Singh sir, Head Department of Mechanical Engineering. Thank you, sir. Now I would request to all the dignitaries on the dais to come up forward for the lighting of the lamp. So please. Thank you all. Now I would request to Dr. Abhishek Tewatia, Program Coordinator of this program, to come forward for welcome address.
Good morning to everyone. I extend a warm welcome to today's esteemed guest, Professor PM Pandey ji, Director of BIT Jhansi, Professor KPS Rana ji, Dean of Faculty of Electrical and Mechanical Engineering, Professor DK Singh, Head of the Mechanical Engineering Department, Dr. Tushar Sharma, Senior Technical Consultant, Research at Ansys ARK Info Solution Private Limited. I would also like to acknowledge the presence of our organizing members, Sanjay Gupta ji, Dr. Vivek Kumar ji, and all the deans, head of the department, faculty members, staff members, participants, students, and media representatives are here today. We are gathered here for the inaugural function of a 2-week industrial training program on finite element analysis and its industrial application using Ansys, scheduled from June 19th to June 30th, 2023. First and foremost, I would like to express our gratitude to Professor J.P. Saini ji, our Honorable Vice Chancellor for his unwavering support and believe in our ability to organize this training program. The objective of this training program is as follows. The course aims to provide the participant with intensive short training on finite element software, which offers a well-defined platform for analyzing problem in finite element environment without creating a mathematical model of the object. It covers various topics including simulation, validation, and optimization of the good and production equipments. The program is designed to offer the practical hands-on experience using industrial software tools, that is Ansys software. Participant will learn to design and simulate various engineering systems, analyze their performance, and optimize manufacturing processes. This training program presents an excellent opportunity for the participant to enhance their skills and gain practical experience. Participant will also have a chance to network with industrial professionals, expanding their careers prospects. The training session will be delivered by the experienced industrial professionals, research experts from academia and research laboratory, and faculty members of NSUT who possess extensive expertise in computer-aided engineering. The training is organized in 2 phases. We have 2 phases. Phase 1. In phase 1 taking place in the first week, which provides hands-on training on Ansys software, fundamental features and capabilities. Various experts from Ansys ARK Info Solution Private Limited will conduct the lectures and trainings during this phase. The topics covered during this hands-on training program in phase 1 is space claim and tools, creating 2D and 3D geometry preparation, mesh evolution and control, structural analysis of 1D, 2D and 3D geometry, among other topics. Then we have a week 2, that is phase 2. In phase 2, in second week we will focus on the advanced industrial and research application of finite element analysis. In this phase, participant will receive training from experienced industrial professionals, research experts from academia or research laboratories, and faculty members of NSUT. This phase will cover the topics such as finite element analysis of composite materials, finite element fatigue analysis, introduction to extended finite element method, that is XFEM, dynamic analysis using finite element and case studies, impact behavior of structures using finite element method, finite element and boundary methods in structural acoustics and vibration, finite element analysis for biomedical engineering applications, finite element analysis for nuclear power reactor, finite element analysis of manufacturing processes application, and multi-physics problem and more. The participants have already received the weekly schedule during the registration. Upon the successful completion of industrial training program, participants will be awarded certificates. Thank you all once again for your presence and support. Thank you very much.
Thank you so much, sir. Now I would request to Professor D.K. Singh, sir, Head Department of Mechanical Engineering, to come forward for his address.
Good morning to all. Dean, Faculty of Electrical and Mechanical Engineering, Professor K.P.S. Rana. Our chief guest of today's program, Dr. Tushar Sharma, Professor Pulak Mohan Pandey, the industry expert, Dr. Tushar Sharma, program coordinators, Dr. Abhishek Tewatia and Dr. Vivek Kumar, program convener, Mr. Sanjay Gupta, faculty members, students, and dear participants. Welcome to 2-week industrial training program on finite element analysis and its industrial application using Ansys, organized by the Department of Mechanical Engineering. The Department of Mechanical Engineering came into existence in the year 2018 when NSIT was converted into a university and became NSUT. The department before 2018 was known as Division of Manufacturing Processes and Automation Engineering. The Department of Mechanical Engineering has an intake capacity of 1 students in its BTech program, and it offers 4 minor specializations to the students admitted in mechanical engineering. They include automobile engineering, robotics and AI, CAD and CAM, and manufacturing and industrial engineering. That is, the degree is awarded as BTech in mechanical engineering with a specialization in automobile engineering, or BTech in mechanical engineering with a specialization in robotics and AI, and so on. We offer a large number of elective courses to our students, and a student has to choose 4 to 5 elective courses for a particular minor specialization. Besides BTech program, we run MTech programs in 2 specializations. One is MTech in mechanical engineering, and another is MTech in CAD/CAM. Both GATE qualified and non-GATE students are given admission in MTech program of the department. We also run full-time PhD program in various areas of specializations like thermal and fluid sciences, advanced machining, composite materials, robotics and AI, welding, industrial engineering and management, and many more. Mechanical engineering at NSUT has undergone many changes in the recent years. We have replaced old and obsolete machine and equipment in most of the laboratories of the department. 5 new laboratories have been established in the department in the recent years. They include mechatronics and automation, advanced manufacturing lab, computation lab, thermal engineering lab that includes the refrigeration and air conditioning along with the heat transfer, fluid mechanics lab that also includes the machinery part of the fluid mechanics. The computation lab is going to be developed, you can say, as a state-of-the-art lab with a sitting capacity of 75. That lab will have all the computing facilities in the lab, and all the important software are required to be installed in the computer systems of the lab. Whereas the advanced manufacturing lab will have machines related to the advanced manufacturing, as the name suggests that we have the CNC lathe machines, CNC milling machine, 3D printers like that. Additionally, we have purchased many equipment for the existing laboratories. It is a great moment for the department. The department has started its first training program of 6 weeks duration on 5th June 23 on Ansys. And this is the second training program on Ansys. Recently, the department has purchased Ansys software. It is a very useful software having immense possibilities. It is a great tool to enhance your academic capability with respect to software requirement. With the help of this software, you can analyze problems relating to design and thermal and fluid sciences especially. It greatly helps in the analysis of a stress-sustained problem. The department was facing the requirement of Ansys software since long back. Its knowledge and use by the student will prepare them to meet the requirement of the industry. It will increase their employability. Additionally, the department has purchased MATLAB and FluidSim. We are in the process of purchasing other software like CATIA, Abacus, etc. In this training program, there are 2 sessions, one in the morning, another in the evening. In the morning session, we have a lecture, and in the evening session, we will have the assignment tutorial like that. I hope you will enjoy this training. With these words, I stop here and wish a great success for the training. Thank you.
Thank you so much, sir. The industrial expert Dr. Tushar Sharma is designated as Technical Manager in ARK Info Solution Private Limited. He has completed both his doctorate and post-graduation from MNNIT Allahabad in Applied Mechanics. He bears an expertise in the field of finite element analysis with hands-on expertise on using Ansys mechanical in broader area of solid/structural mechanics and composite materials. Sir has published various papers in international journals and conferences. I would take an opportunity to invite Dr. Tushar Sharma, industrial expert from Ansys ARK Info Solution, to come give his speech.
Thank you, ma'am. So first of all, I would like to welcome on behalf of Ansys and ARK our chief guest of this program, Professor PM Pandey sir, VC sir, NSUT, Rana sir, then HOD Mechanical sir, and convener and coordinator Sanjay sir, Abhishek sir, Vivek sir, and lovely audience. Thank you and welcome from my side. And so this has been my second talk in two weeks of time. 2 weeks before, when we started a 6-week training program on Ansys, that time also I have been called as an industrial expert. So many of you have heard me during that time also. So this time, what is the difference? So already we have started the 6 weeks program. Now we are starting this 2 weeks program. So basically, both the programs are having their own flavor. So this 2 weeks will be a completely packed jam on the industrial applications where Ansys has been utilized. And whereas those 6 weeks programs consist of the basic learning of Ansys starting from the scratch side. So that has been the major distinguish between those two programs. And if I talks about the NSUT and Ansys collaboration right now. So last year when Ansys was procured in NSUT, we conducted a 1-week program, a training program. We have seen the audience loving to learning the Ansys tool. That time itself, me and Abhishek sir have discussed about that what all things we need to do in the future for the NSUT, for the participants, those who are coming from the outside, they can learn Ansys. And keeping that vision into the mind, Abhishek sir has been working day and night, hard work related to organizing such wonderful program, and the result has been in front of us today. And if I talk about the collaboration, Ansys offered 2 sponsored MTech students to the NSUT, 2 industrial sponsored MTech, fully sponsored MTech students are being given it to the NSUT. And when during the installation and during the training program, we were been in a planning of searching for one student or we can say one candidate to be joined in our organization. And that time we were struggling to find the student. And surprisingly, when we are doing the training and all those things, why we are struggling is because we could not able to find a skilled manpower who knows Ansys, who is working onto the industrial application side. And again, for that, I would like to thank Abhishek sir, who is working into the areas of industrial projects. So I have seen the candidate, seen the project onto which he is working, and I could able to understand, yes, he is the right candidate, and that candidate is been working with us, even though he has not completed his MTech that time. His final defense was pending, but we have rolled out the offer letter to him. So that has been the advantage of learning a tool which is being utilized into the industry. So that is the main ideology behind organizing such industrial training, to motivate the faculties, to motivate the research scholars, those who are been working and those who are our future faculties, so that when they guide their students, they work onto the industrial applications which will be benefited to their student itself, so that the placement rates will goes higher.
And I can assure you, as a person from the industry, there are a lot of vacancies into the industries right now. It is a myth that there is no placements or there is no vacancies in the industry. There are a lot of scope in the industry right now. But the problem is industry don't wanted to spend that much of energy, that much of resources to develop the skill into the new joinees. So if you could able to develop the skills into in yourself during your course period, during your BTech, MTech, then it will be very easy to sell you out to the industries. And industries are looking for such kind of candidates only. So that has been my message from my side. So learn the industry tools which will be benefited for you, for your students, for your career. Thank you.
Thank you so much, sir. We have one virtual message by Professor Varun Chaudhary, Assistant Professor in Chalmers University, Sweden. So I'm going to play that.
Hello everyone, warm greetings from Sweden. My name is Varun Chaudhary. I am currently a faculty member at Chalmers University in Sweden. Previously, I had the position of senior scientist at Nanyang Technological University in Singapore. My current research focuses on accelerated materials discovery for a sustainable future, employing high throughput methodologies such as additive manufacturing, thermodynamic modeling, and machine learning. I would like to emphasize the crucial and significant role that modeling and simulation play in the development of materials. Ansys is wonderful software for modeling of multi-phase materials and structures. Many research studies have attested to the fact that the precise machine capabilities in Ansys lead to the materials properties closely aligned with the experimental results. However, expertise in using the features being the key constraint. I do appreciate the efforts of organizing committee members of Netaji Subhash University of Technology, India for organizing this training program. My heartfelt wishes to all the participants for adding an important related tool within their large vessel of knowledge. I wish this event a grand success. Thank you very much.
Thank you, sir. The chief guest of this program, Professor Pulak Mohan Pandey, Director BIET Jhansi, completed his BTech from HPDI Kanpur in 1993, MTech from IIT Kanpur 1995 with manufacturing science specialization, and PhD from IIT Kanpur in 2003 in the area of additive manufacturing and 3D printing. He have almost 8 years of experience from HPTI Kanpur, and after that he has joined IIT Delhi in 2004 as a faculty member. In IIT, Professor Pandey diversified his research area in the field of micro and nano finishing, micro deposition, and also continued working in 3D printing as well. He supervised almost 42 PhD, more than 36 MTech theses in last 10 years, and also filed 23 Indian patent applications. He has approximately 219 international journal papers and 50 international national referred conference paper. His research citation is 10,180 times with H index 51, and this is not only there are a lot of more achievements which I cannot read over here in this short span of time. So it is my privilege, I would take an opportunity to invite chief guest of this program, Professor Pulak Mohan Pandey, Director BIT Jhansi sir, to give his blessings to us.
My colleagues and friends on the dais, various participants from, I don't know, from the various parts of the country maybe, or students from NSUT Delhi, which I can see, faculty members of NSUT Delhi, and dear friends, ladies and gentlemen. It gives me pleasure this morning to be here as a part of this inaugural function, as well as you might have seen the schedule that I also have a lecture to be delivered in the area of this course which has been planned for finite element method. So I will not say much because I have another 1.5 hours to speak about finite element method. But the message which I would like to give you is that today it is the time when it's not only the fundamental knowledge about a subject, maybe design, mechanical design, maybe manufacturing, or maybe analyzing a mechanical engineering problem using a finite element tool, and some of the standard tools which includes Ansys is something which is required. Now, what I personally feel that the students today should not use these tools as a black box. Generally, what happens is that these tools are used without having the fundamental understanding about the subject, and in that case, the problem which student faces and also the organization where he or she is working that is being faced is that you lose your time, and sometime you end up with an ambiguous solution or a solution which is actually not correct. So in order to avoid these kinds of situations, the suggestion is that instead of only relying on the softwares, the theoretical background of a particular software must also be studied. That is the important message which I would like to give here in this program. Today, as we know, this finite element method, which was developed long back, maybe sometimes around 1945 to 1950, in between this period, this particular tool people started thinking about. And if I remember my days when I did a course on finite element method in IIT Kanpur, my professor, even today I remember that there was some engineer or scientist named Clow who actually brought out this particular idea around 1947 or so, when actually our country was undergoing the independence phenomena. It was the time when this particular tool was started developing. And today, if you really see, so at that time this tool was only for structural problems, and in the very beginning it was to solve a problem which was based on the complicated trusses. And if you really try to understand a complicated truss, the structure which is on the various ribs and the continuation of various ribs in tandem, that is the aeronautical structure or a structure of this aeroplane. So in the very beginning, this particular tool was developed for solving such kind of typical problems. Later, with the development of continuum physics and also with the development of various physics-based models for solving a continuous domain, the different kinds of formulations were developed, which includes the variational methods, energy methods, or the weak formulation, which is also known as the Galerkin's approach. And the idea behind the finite element method is that in a complex domain, and if the variation of a particular field variable is complex in nature, you will hardly find a mathematical function which is either polynomial based or which is based on some other mathematical function which can approximate in a larger domain. So the idea is that you divide the domain into small pieces which is called elements. So depending upon the kind of problem you have, you may have a problem which is one dimensional, so you can have a linear element having different nodes there, and then within that particular element you can approximate your field variable with either as a linear variation or a quadratic variation. And when you reduce the size of the element, you will find that in pieces you can approximate even a complex behavior with small line segments. So that is what is the basic idea of finite element method. But in order to make this problem mathematically correct, there are number of conditions like completeness, compatibility, etc. They are to be followed. Correct? Now, there's another problem which comes when you do the finite element method. That is the geometry which is involved. Like if it is a two-dimensional problem, the geometry may be a typical geometry involving free-form curves. It may also have, if it is a three-dimensional problem, the domain may be having the boundaries which may be some sort of free-form surfaces, maybe B-spline surface patches. So how you are going to approximate the boundary also along with the field variable. So then the concept of some elements like isoparametric elements or subparametric elements, that was developed. Generally, if you try to see the various kinds of engineering problems, you will realize that the engineering problems may be governed by some differential equation. And the differential equation which you are having to be defined over a domain along with the boundary conditions or the some sort of initial conditions. That is to be solved provided the analytical solution you cannot do, provided there are other simpler techniques which are unable to solve it. We should go for finite element method, which is a numerical method. Is it okay? Now this numerical method will give you a solution, and definitely the solution is to be something which is to converge, which has to satisfy the convergence criteria. Then only you can take the solution as granted, and if the problem of the physics is established, only then you should use a particular standard software. Now, today in my talk, I'll show you one manufacturing problem being solved by finite element method. And I don't know, I would like to seek the comments of the experts from Ansys after my lecture, that even today whether the capabilities which I'll show you, they are available with Ansys or not. Second is about the limitations of finite element method. Like there are methods which have been developed over the time, like boundary element method. In CFD, it is the finite volume method or the finite difference method, which is given preference over finite element method. Is it okay? Then it comes the meshless methods. Today, if you try to see, it is the meshless methods where no meshing or no discretization is something which is being carried out, even though people are trying to find out the solution. So that developments are taking place, and the students and the faculty members, they are supposed to cope up with the development which is taking place. Now, today it is the trend when we talk about the artificial intelligence and machine learning. Today it is the time when we talk about, rather in manufacturing, I'll say that the statistical tools, they have been also quite popular. The idea of finite element method, which I would like to say is something which is quite deterministic in manner, is sometimes unable to take with it the fuzziness or the stochasticity which is present in the system. In those circumstances, you will realize that the predictions of finite element method are sometimes, they are little away from the actual situation. So, in a circumstance or in a particular situation or for a particular solution of a problem, you have to see that which tool is to be used. We should not blindly follow any tool. Today, we are talking about digital twins. These digital twins are actually the models which are replacing somewhat the conventional finite element models. And today, if I am correct, the Ansys has also launched a version where you can develop a digital twin, correct? And these digital twins are somewhat can be modeled, or rather they work on the principle of machine learning, where the actual field data is being used to train a neural network. That may be a deep learning solution. And then this particular trained neural network model is utilized to display the field variable over the particular product or maybe system, whatsoever it is. So you are calling it as a digital twin. So I don't know, because I never get this opportunity to work with the software of digital twin, having the module of digital twin of Ansys, but I can just imagine that the idea behind it may be using some sort of physics-based solution and some sort of actual solution trained by a machine learning model, putting them together may be a better model which can be used by the user or by the industry for the purpose. So today, as a professor of mechanical engineering, without having any bias from any particular method, because I have seen in the society, people are highly biased about a particular method. Like if I am an expert of finite element method, I'll say it is the best method. If I am a professor of additive manufacturing, I'll say the life is only additive manufacturing. All other things are a waste. That's not correct. Correct? So you have to see the situation, you have to see the problem, and you have to find out a very appropriate tool for solving that particular problem. As an engineer, as a scientist working for the society, as the objective of this course is also that you have to solve the industrial problems which are more application oriented. So as an engineer, you are supposed to provide a solution, and the solution must be most accurate solution. I will not say the perfect solution, correct, to the society. So that is the goal of the engineer. So this finite element method course, which I was trying to critically see that many of these sessions which have been planned, which are hands-on in nature, are definitely going to be very helpful to most of you, but you ask number of questions. That is very important. Do not follow the things in a very blind manner. Do not use the tool like a black box, correct? So I hope that this particular course will prove very fruitful to all participants, and this will definitely help you in terms of solving new problems and also for your better career prospects. I thank once again to the organizer of this course for taking pain and organizing a 2 weeks long program. And you have to keep your patience also, because sitting in one room morning to evening and keep on doing the things with the same set of people, with the same set of tools, is something which requires a lot of patience. So I hope that you will go away, you will carry on with the patience, and you will have a very fruitful stay with this program at NSUT. Thank you very much, and thanks for inviting me.
Thank you so much, sir. Now I would request to Professor KPS Rana, sir, Dean FEME, to come and bless us.
Good morning. Dignitaries on the dais, Professor P.M. Pandey, Director BIT Jhansi, Chief Guest of the Inauguration Function, Dr. Tushar Sharma, Senior Consultant from ARK Solutions, Professor D.K. Singh, HOD, Mechanical Engineering Department, Mr. Sanjay Gupta ji, Convener of the FDP, Dr. Abhishek and Dr. Vivek, Program Coordinators, esteemed faculty members, participants from industrial training, distinguished guests, faculty members, ladies and gentlemen. Good morning to you one and all. First and foremost, I warmly welcome you all on this momentous occasion of the inauguration function of our FDP in FEA and its engineering applications in Ansys. I welcome Professor P.M. Pandey, Director BIT Jhansi, Chief Guest of the FDP inauguration function. Thank you, sir, for having accepted our proposal. Your benign presence and expert talk will inspire and motivate the participants. As a Dean of the Faculty of Electrical and Mechanical Engineering of this esteemed university, I am pleased and proud to stand before you on this auspicious occasion. We have gathered here to mark the inauguration of a program that will play a pivotal role in shaping the future of mechanical engineering education in our institutions. The field of finite element methods or finite element analysis has revolutionized the way engineers design and analyze complex structures and systems. It has wide-ranging applications in aerospace, civil, mechanical, and beyond. Finite element analysis has become an indispensable tool for modern engineering practices. FEA simulates any physical phenomena using the FEM techniques. The FEM is popular for numerically solving differential equations arising in engineering and mathematical modeling. It is used in structure analysis, heat transfer, fluid flow, mass transfer, and electromagnetics. To solve a problem, the FEM subdivides a large system into smaller, simple parts called finite elements. This is achieved by space discretization, which is implemented by constructing a mass of objects. One of the main trends in FEA is the integration of different scales and physics in a single model. This allows for more realistic and accurate simulations of complex systems that involve multiple interactions such as biomechanics, nanotechnology, composite materials, etc. However, multi-scale and multi-physics modeling poses significant challenges as well, such as computational cost, data availability, model validation, and uncertainty quantification. Therefore, FEA engineers must master the principles of these type of modeling, such as homogenization, adaptive meshing, coupling strategies, and sensitivity analysis. A recent trend in FEA is applying machine learning and artificial intelligence to automate various aspects of FEA, including data processing, model generation, parameter estimation, optimization, and error correction. AI and ML can help you overcome some of the limitations of traditional FEA methods like non-linearities, discontinuities, inverse problem, and large-scale problems. However, they also introduce some challenges to data quality, interpretability, robustness, and ethics. So, it is also important for FE engineers to acquire skills of AI and ML. In this era of rapidly advancing technology, faculty members must remain at the forefront of knowledge and expertise. By embracing the latest tools and techniques, we can effectively impart quality education to our students, preparing them to meet the ever-evolving challenges of the industry. Through this faculty development program, we aim to equip you all with the necessary knowledge, skills, and expertise to excel in FEA domain. One of the cornerstones of this program is the incorporation of Ansys, a renowned software for engineering simulation. Ansys has been at the forefront of innovation in finite element analysis. Ansys offers engineers a comprehensive platform to analyze the behavior of complex systems, predict performance, and optimize designs. By integrating Ansys to this FDP program and providing a training to faculty members, we are again granting a competitive edge to address real-world engineering challenges. The FDP must be treated as more than a technical skill enhancement. I'm sure it will also be a interdisciplinary research, breaking down disciplinary boundaries and encouraging cross-pollination of ideas that can unlock new avenues of innovation and creativity. I want to acknowledge and put on record the efforts put in by our mechanical engineering department in shaping this FDP, particularly the sincere efforts of the head of the department, Professor D.K. Singh, convener, Mr. Sanjay Gupta ji, and coordinators, Dr. Abhishek and Dr. Vivek are praiseworthy. I had the opportunity to participate in few meetings with them. They have meticulously designed the program to create an ecosystem of learning and exploration. They have developed a comprehensive curriculum that covers the fundamental principles of FEA, advanced analysis techniques, and practical implementation using Ansys software. Several renowned experts have been roped in addition to Dr. Tushar, who will be associated with us throughout the program. Dr. Tushar has strong expertise and long-standing experience in Ansys. Overall, you will undergo rigorous training sessions, allowing you to delve upon the intricacies of finite element analysis. Learning is a lifelong journey, and as a faculty, we must continuously adapt and adopt knowledge. This program will serve as the foundation of a continuous professional development pathway, offering further specialization and advanced training opportunities. You should be encouraged to stay abreast of the latest developments in the field, attend conferences, publish papers, and actively participate in professional societies. As a faculty member, let us embrace the spirit of exploration, innovation, and collaboration. Let us strive to make our institutions a hub of excellence in FEA analysis and Ansys engineering applications. Together, we can empower next generation of engineers and contribute to advancing technology and society overall. I extend my heartfelt gratitude to our organizers and the participants for their unwavering commitment to this program. Your dedication to professional development and continuous learning is truly commendable. The knowledge and expertise gained through this program will profoundly impact teaching methodologies, research outcomes, and most importantly, student success. Thank you, and I wish you all a fruitful and inspiring journey on finite element analysis. Thank you again.
Thank you so much, sir. Now, I would request Professor KPS Rana, sir, to felicitate Chief Guest of this program, Professor PM Pandey, sir, Director BIT Jhansi. Thank you so much, sir. Now, I would request the program convener of this particular program, Mr. Sanjay Gupta, sir, to come and deliver his vote of thanks.
Distinguished guests and all the participants, I'm here to express my heartfelt gratitude and extend a warm vote of thanks on behalf of organizing team. It has been an incredible journey filled with memorable moments and invaluable experiences. First and foremost, I would like to thank Honorable Vice Chancellor Professor J.P. Sani sir for giving us the opportunity to conduct this program and providing all the support from the university. Thank you, sir, for your belief and support in us. I take this opportunity to extend our most sincere thanks to our chief guest, Professor PM Pandey sir, for gracing us with his presence and sharing profound insights and knowledge. Your wisdom and expertise have enlightened us all and inspired for future. Thank you, sir. I would like to thank Professor KPS Rana sir, Dean FEME, for continuous guidance and support for making this program possible. In fact, we are meeting on day-to-day basis for last 10 days. I extend my thanks to Professor D.K. Singh, HOD, Mechanical Engineering Department, for all the supports. A word of thanks goes to Dr. Tushar Sharma of Ansys ARK Info Solutions and his team for extending their technical support and contribution for the program. I would like to acknowledge the hard work and dedication of both our coordinators, Dr. Abhishek Pevatia and Dr. Vivek Kumar. Especially Dr. Abhishek has been instrumental for all the groundwork and sharing large amount of hardship. I extend my deepest appreciation to our organizing committee, especially Dr. Swati for anchoring, whose tireless effort and meticulous planning to the flawless execution. Your commitment to excellence has ensured a seamless and unforgettable experience for all the participants. Furthermore, I want to express our gratitude to the media and press who have covered this event. Your presence and coverage have helped us reach a wider audience, spreading the message and impact of this event far and wide. I would also like to acknowledge the hard work and dedication of our volunteers and staff members, especially Ashish ji, Vinod ji, Atul, and Himanshu ji. Your selfless service, enthusiasm, and commitment have been the backbone of our success. Thank you one and all for being with us in this journey. Thank you.
Thank you so much, sir. Now I would request to everyone, please stand up for national anthem. जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंग तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे. Thank you everyone. You all can cordially invited for high tea at outskirts of this APJ 11. The next session will be delivered by the chief guest of this program, Professor PM Pandey sir, at 11:30. So be present here only at 11:30 a.m. Thank you everyone. The student can go for high tea at right side of this room. left side. you to make a profit at the game of your choice. So, with this thought, I would like to invite our industrial expert, Dr. Tushar Sharma, to give the lecture on the particular Ansys. Thank you, sir. Come forward.
Yeah, thank you, ma'am. इस पे आ जाएगा पक्का स्लाइडर कहाँ है
You can use this. Okay.
हाँ हाँ नो इश्यूज नो इश्यूज ये तो ये फुल स्क्रीन आना चाहिए ना एक सेकेंड ये स्क्रीन पर स्क्रीन का उस पर नहीं आ रहा
अच्छा, इस पे है, इस पे।
इसको इस पे करेगा आपका ये चल रहा है नहीं तो इसको इस पे कैसे लेके आएंगे
ये इस पे नहीं आएगा, ये तो पेन ड्राइव लगा के आएगा, ऐसे नहीं
तो ये डायरेक्ट नहीं यूज़ कर सकते?
आएगा। ये डायरेक्ट उस पे जा रहा है, इस पे
हाँ,
नहीं
तो
आएगा।
कोई बात नहीं, यूज़ करने दीजिए वो। ठीक है सर, यूज़ करिए।
यहाँ से कर दिया ना। नहीं वो कैसे हटाना पड़ेगा? ये फाइल हटा दो,
The laptop is not connecting with that.
फाइल हटा दो, एक सेकेंड।
No, no, it is okay.
ओके थैंक यू So good morning everyone. Good morning everyone. Now everyone is awake. So let's start with our session with Ansys solution for academia. So most of you have heard about the things which I need to be go through here, but there are some few additional points which I have been added here. So let's move on with the very basics. So we all know about the Ansys. What is the Ansys? Ansys is a simulation tool. So why we need a simulation? So let's go back and think how do our industry works. So our industry works with the manufacturing process of using our traditional machines, lathe, milling, drilling, all those manufacturing processes are been happen onto the product. So can we able to give the shape, desired shape, any complex shape to any of the product? No, because we do have a limitation to work it on. Okay, then there are lot of things which we need to look into when we are designing any product. Whether it stands that much of loads, whether it can have that much of strength uh, uh, with respect to the application where that product is being utilized. So thinking towards the physical application of that particular product, we need to test it. So testing, there are very simple process previously. Let's suppose if we wanted to test any particular object, and we today the example of mobiles. So initially, if you remember, there are very delegated mobiles which are been coming. If they are fall even first time itself, your screen will be cracked and your mobile is gone. Yes, but now you have seen multiple times your mobile has been falling, but still it has been working. There is nothing been happening onto the screens. Why it is so? Because it is been tested multiple times and check over it whether it will fail or not. So think it of, if we manufacture a mobile and start throwing it one time, second time, third time, fourth time. So into that particular process, how many times that screen may crack, and how many items of mobile as a number we are been wasting only for testing it up. So there the simulations comes into the picture to reduce the cost, first the thing, and which is the foremost part. So to reduce the particular cost, we just simulate it under the same physical environment where it has been the loading and the environment under which that particular component need to perform, and we will simply drop it virtually and check whether the screen will crack or not. In simulation, we do have the iteration processes. Either you can go it for 10 times, 100 times, 1000 times, depend upon your computational cost, you can perform it. So once you are being satisfied with your simulation results, then you can move on to the single manufacturing of the component and you can do the testing. So you can see how much you can save, and which comes to the few major points is, why do we require a simulation? To help meet product code regulation. There are always some codes. You have heard many places it has been written, this particular product is ISO 201 certified, ISO 2225 certified. What is those codes? ISO. Those are Indian standards based upon which any of the product need to be certified. Okay, so for attaining those things, it requires the rigorous amount of analysis behind it or rigorous amount of testing behind it to confirm that yes, this product has the ability to come under the certified of ISO. So that can be very much helpful by the simulation module. Then product design, definitely the improvement in designs. Previously you have seen there are lot many very basic manufactured products are being there, not so complex, but recently you have seen a very complex structures are being designed. It is very easy to design all those structures. Why? Because nowadays we do have a 3D printers which doesn't have any shape limitation with them. So these are the new tools which are being utilized into the manufacturing, which can be simulated by the simulation module. Then root cause failure analysis. Let's suppose if we are dropping our mobile phone, okay, what is the root cause of that particular failure? We don't know whether the failure is being due to the battery or due to the glass of the screen or due to the plastic body or a metal body of the mobile. We don't know. We only see, okay, we are throwing it up, it is breaking, but we could not able to find out the root cause of it. So how to find out the root cause? Again, the simulation plays a important role in finding out the root causes and providing the solution to them. And lastly, reduce time cost of the product. We have already seen it will reduce the time while simulation, Otherwise, we need to go onto the production line, developing a new mobiles, throwing it, and then keep piling our data, and then we will come out with the new products. But now you can see with the simulations in place, the lot of products are been launching at a very short duration of time. That is being a power of simulation. Okay. Then these all are the few things which institutes are been working on using the simulation side. They are driving the innovations. You all are the inventors. As a students, as a research scholar, you are the inventors. You are being looking it up for setting up a new startups. Your ideas are been coming up for the new products into the market. Then you are been thinking of doing some complex problems, solving some complex problem into it. Earlier, what we used to do in our MTechs and PhDs, people used to work on the plates and shells. Okay, they are not moving ahead of it. But now, using the simulation part, we are moving with the complex structures. Okay, we are been designing, manufacturing this wind turbine blade, which is the most complex structure in the aerodynamics. So you can see applications are the same of plates and shells only, but we are implementing those plate and shell theories into the wind turbine part. So we are increasing the levels of complexity. Then lower cycle time, reduce cost, increase the quality. So again, I'm taking the example of mobile itself. So previously, the quality was very poor. If it is fall down, your mobile screen is gone. But now, even though after multiple damages, your mobile screens are workable. Even you will get a dent into your screen. Your screen is cracked, but still you could able to operate it. So why it is been? Because the quality is been increased. And estimated risk is minimum. Okay. So now again, if we talks about into the numbers, so the complexity of the product has been increased by the 64%. So now we are not dealing with the normal products. We are been talking towards the complex structures. Nowadays you have seen the new mobiles which are been coming. Since we are been dealing with the example of mobiles, you have seen the new mobiles of Samsung and Motorola which are been coming with the flaps. Okay, flap without any bend. So if you flap it, it will become a small mobile. If you open it, the screen will be plain and you can utilize as a big mobile phone. So what is this? This is the complexity level. So we are increasing the complexity level by utilizing the simulation. Then product must be delivered to the market faster. Obviously, with the using a simulation, with the power of simulation, products are being delivered to the market faster. And that is 61%. And the quality of product has increased by 45%. So these data are huge in terms of the invention which has been going on through the simulation side. Now, if I talks about the Ansys, what are the advantages of Ansys being a market leader for simulation is, first, high-end multi-physics simulation. So what is a multi-physics? How to utilize multi-physics? I will take you through in my presentation ahead. So the simple thing is, you need to remember multi-physics means multi-physics. When one or more than one physics has been involved in simulating any of the problem, it will be counted as a multi-physics. Either it is a structural, including with the CFD, either it is a structure including with the electronics physics. So it will become a multi-physics problem. So it is very easy to be operated in Ansys multi-physics problems. Then robust, liable workflow for developing any project. Seamless setup and design studies. Very simple process will be there. Just you need to drag and drop. All the modules are being there. You need to click it, drop it, and input all the data into it. Fast simulation runs, as Ansys provides the support to the HPCs for the faster simulation part, and even now Ansys has been fully operating on the GPUs also, which will reduce the time of simulation from 10 hours to 2 hours itself using the GPU power. And lastly, training and mentoring program. So this has been a kind of training and mentoring program which has been run by the Ansys into the NSUTs, since NSUT is a prime customer of Ansys itself. So now if we talk about the Ansys, okay, so you have seen, you are knowing about the complete life cycle of any product. So the life cycle of the product start with some idea. When that idea gets matured, it goes into the design phase. Okay, in those design phase, we need to validate the design, whether that particular design, what we are thinking, will withstand all the physical environment or the condition onto which we are been thinking it will be liable for. Then after the design phase, it will goes into the manufacturing. Okay, after manufacturing, it will goes into the operations part, because under the manufacturing stage, after it, the lot of operation need to be performed, and then it will goes into the product phase. Okay, so this is the complete life cycle of any of the product. So Ansys do provide solution at each stage of the product, starting from the idea. As PM Pandey sir is saying that there is the lot of theories which are been going on, starting from finite element, then finite volume method for CFD and fluid analysis part, and he has also mentioned one name as a meshless theories. So Ansys do have a solution onto the meshless itself, and that is the Ansys Discovery. So at the initial phase of your idea, you wanted to qualify your idea, whether if I take it to the design phase, whether it will qualify or not. So at that particular phase, Ansys Discovery, we do have a tool where you can design it. Instantly you can change the design and you can check whether what are the deformations and what are the stresses. They are not so accurate as the finite element one, FEA one, but yes, it will give you the approximate solution, yes, whether the idea which we are been proposing to the design team, whether it is a liable or not. So we have a solution called Ansys Discovery for the idea stage. Then for the design phase, we do have our flagship products like Ansys Mechanical, Ansys CFD, Ansys Fluent. All those flagship products are being utilized to validate the design, what we are been proposing. For manufacturing, these days, as we are talking about Industry 4.0, we are talking about additive manufacturing part, 3D printers, metal 3D printers part. So you all know printing any product through the metal 3D printer, it requires a huge amount of cost into it. It will take a lot of effort to print any particular component into the metal, since the metal, I can say, the material itself is very expensive, and the metal 3D printers are being cost into itself in crores. So once you are been developing any component, there are a lot of deformations, stresses, distortions are been happening onto the additive part itself while cutting the component from the base. There are a lot of distortions are been happening to the component. So while you are been printing any component and wanted to install it at any particular location, if it got distorted, it will not fit into that particular space. So your complete effort of modeling or developing the product through a metal 3D printer will got into the waste side. So rather than again going into the printing side of additive, first do the simulation using Ansys additive manufacturing module. Look into what are the stresses, what are the distortions which are been coming. If the distortions are been coming more than what you are been expecting, additive module have the negative distortion algorithm which will guide you to change the design shape, so that once you will get the final product, it will be of the same shape and size what is been desired. So manufacturing portion will be covered by the additive manufacturing part. Then if we talk about the operations, into the operations, whether my component which we have prepared is having that much sufficient of maintenance part into it, whether it can withstand the warranty period, which is a very important part. So these days we have seen the companies are been giving more warranty into the products. Yes, previously all the machine electronics part maximum they gives a 1 year of warranty, but now you can see they are providing 3 years of warranty, 5 years of warranty. Why it is been so? Because they have tested their component, they know it, okay, under this particular environment, if this particular component works, it will not fail for the 5 years. So if at all the component is been failing before it, their inventory goes down, because the lot of defective components will come back and they need to give the new components to them. So they need to work on to that part. So Ansys do have, which again PM Pandey sir have been discussing about the digital twin for predicting the its maintenance. Okay, so that tool is being utilized under the operations category. Okay, then lastly is the in product part. So in product will be the complete assembly of the components which we have prepared. So let's suppose take a example of ADAS vehicle. So what is an ADAS vehicle? Anyone? ADAS, you have heard the name of ADAS vehicle? A vehicle which doesn't have any driver. It will drive it automatically. Yes, automatic driving assistance system. So can you imagine it can be physically possible? And even in Indian conditions where a person can run onto the road from nowhere. Yes, don't take a conditions of man. We can say a cow was grazing nearby the road. Suddenly what happened to a cow? It will comes onto the road. Yes, those situations are been happening. So under that conditions, do you think we can take that much of courage to run a ADAS vehicle onto our Indian roads for testing? Because this again, testing it requires a huge data, huge hours of data for developing the ADAS vehicle. Then only we can claim that yes, it is being and implemented, no driver is being required. If any obstacle comes into the picture in front of a car, automatically a brake will be applied. Can you imagine it can be possible without a simulation? No. If we are being again testing it through the through our processes, it will take thousands of years to collect all those data. But yes, this is being happened only and only by the help of simulation, that under the 3 to 4 years of time span, we have collected that much of simulation data and we are being launching the ADAS vehicle into the foreign. And even in Madhya Pradesh, I have heard that news that students are being successfully able to develop the ADAS vehicle. It is not so accurate, but yes, they could able to develop that vehicle. So that much of sophisticated tools are being available with the Ansys to work it on. So that is been the idea behind, to tell you that for the complete life cycle of a product, at each stage there is been a simulation required to support the development of that particular product. So why Ansys has been a market leader? So you must have about this slide. So, and this has been a fact that Ansys is a market leader because it has the largest or a size, I can say 2x size of a competitor. So in terms of a revenue. So you can imagine how big is the Ansys in terms of simulation with the other competitor part. In nearly in all the industries, Ansys has been utilized for developing their product. They are being given as a tag of #1 simulation. Why it is? Because they are being focused on the simulation itself. They are not working on to any of the hardwares. Okay, whereas other competitor do have the hardware as a primary objective and simulation as a secondary part for them. So just for the sake of selling their hardwares, they have developed their own softwares to complement the hardware part. But Ansys is a sole company which only and only works on simulation. That is being the focus of a company. Then Ansys being indexed by the NASDAQ, which comes under the 100 the listed companies of the world. We have overall commitment by the satisfactory feedbacks from the customer side, which is 89%, which is a very big in terms of the global industry under which Ansys has been working. And Ansys has been capable of having, this is the old data, now this is 6,000 plus employees, direct employees working into the Ansys, along with the channel partners across the globe. Then why we call it as the best of breed in Ansys simulation part? We do have a common platform which is being called as a workbench. Those who have know about the Ansys then must know about the workbench. So workbench is a common platform where all the physics are being available, where all the material informations are being available, irrespective of the physics. And all the physics domain part, fluids, mechanical, which we called it as a structural, electromagnetics, semiconductor, mission critical, embedded software, optical, all these modules are being kept under the single platform part. Now, this has been the important slide which showcased the entire portfolio of Ansys. Okay, so Ansys started with the structural part, as PM Pandey sir has told, that in early 1950s, this concept of creating a commercial code has been starting into the finite element part. So there is a very interesting story when Ansys, this commercial code has been created and it has been given it to the company. So people has laughed that who will utilize this commercial code when everyone wants to write their own codes. Okay, but he has taken the challenge and he developed his own startup at that time by providing the customized solution to the industries. You utilize my code and you will get the result out of it. And it started with the Ansys Mechanical, and those who knows about it, Ansys Mechanical APDL, a black window APDL was there initially. So it started with that part, and slowly and steadily the improvement is being started into adding into that part. Industry started adopting it, because for industry developing their own codes is very difficult. Okay, because they wanted to invest their time in building up a product rather than to invest their time in building up the codes. So industry found it very useful. So industry started adopting that part, and slowly and steadily for next 30-40 years, Ansys purely focus on structural part itself. Then Ansys understood the market trend that if you wanted to being a market leader into the simulation, they need to expand that portfolio. And from there, they have started the vision of acquiring the tools, acquiring the market leader tools. So they started with acquiring the CFD module, which is previously called it as a Fluent and Gambit. So people are been utilizing, those who are been working into the fluid side, they know about the Gambit and Fluent combination for pre-processing and post-processing part for solving the CFD problems. So Ansys acquired Fluent, and which has been a market leader into the CFD that time. Starting from there, they expanded their portfolio into the fluids part. So you can see this has been the structural domain part, what all tools are being added right now. Then it goes to the fluids, then to the electronics, semiconductor, you can see safety analysis part, mission embedded software, materials. Then we do have the connect with the cloud server part. Then digital twin has been there. Then 3D design module is there, Ansys Discovery. Then AV escalator for ADAS applications, acoustic simulations, and recently acquired optics and photonics module are being also available. So those who are been working into the optic sides, those who are been interested in, let's suppose if you are been interested in designing up of camera. Okay, so if you are been designing a camera, what is the essential 3 parts of a camera? There is the first one, which will be invisible part is a detected sensors, okay, imaging sensors, which has been invisible into your camera. Then the second one will be the lenses, okay, and third one will be the structural of where those lenses are being attached. So for those part, if you are being interested in working onto the sensors, so photonics modules are been there, Ansys numerical. If you are interested in developing a lenses, then Ansys ZMax has been there. And if you are being interested in simulating the complete structure of camera, let's suppose, so Ansys SPIOS has been there. So related to the entire optics part, Ansys do have recently acquired all those modules. So this has been the complete product portfolio of Ansys which has been available. And as of now in NSUT, you can see structural fluids electronics and few of the products of semiconductors are being available in a institute right now, which institute has procured last year. Now, if we talk about the simulation products, so you can see all the physics-based structural fluid electronics are being there. Then if we talks about the system simulation, so if we start, we can see digital twin has been there, systems of there, embedded software and safety analysis has been there, which are being the major of these tools are being utilized into the electric vehicle development. Then system of system, if it talks about, then digital mission engineering has been there. These days, many of the students, many of the universities are been focusing it on developing satellites. Okay, so how to track those satellites when they are being revolving around the Earth while launching, what will be the communication with the Earth station to that particular satellites. So all those things can be done with the system of system simulation with the digital mission engineering. Then the simulation platform will include the materials, clouds, HPC, optimization, process and data management, and multi-physics part. And if it talks about the academia part, so different industries related to the research part is aerospace and defense, automotive, energy, healthcare, high tech. All these energies, all these industries are being utilizing Ansys along with the solutions like autonomy, electrification, 5G, IoT, sustainability. So these are the buzzwords of to the solutions which are being provided to the industries, with the applications starting from a chip packaging system which has been really booming into the industries right now. Government is heavily investing onto this semiconductor part, because the vision of the current government is to set up India as to be the semiconductor hub, manufacturing hub. So these electronics liabilities, turbo machineries, so lot of demand and focus is being working it by the government into these particular applications right now. So these are the few world-class companies which I have kept it segregating with the different industries, starting with aerospace, constructions, telecommunication, automobile, healthcare, consumer, and automation part. So all these different categories, if you can see, starting from the Airbus, Volvo, EOS, then Schneider, you can see Electrolux, Whirlpool, Nestle, Philips, Pfizer. All these multinational companies are being utilizing Ansys into their product development in any of the phase. I cannot say that in all phase of the product, but yes, in any phase they are being utilizing the Ansys software. Then this is been the list of academic customer for Ansys, which has been again starting from all the IITs and NITs, state governments, private universities. Now I will quickly take you through the Ansys products which are being into the structural portfolio. So starting with the structural products. So the first one is the Ansys Mechanical, which is the flagship product. Ansys started with this particular product itself, which has been utilized for finding out the linear, non-linear analysis, finding out deformation, stresses, buckling, All those kinds of simulations can be performed using Ansys mechanical part, irrespective of linear and non-linear. Either it can be the structural non-linearity, material non-linearity, contact non-linearity. All those kind of simulations can be performed. Then Ansys LS-DYNA is been an explicit solver which is been recently acquired for the applications like impact analysis, crash analysis. Okay, so if you are being interested in finding out the solutions for the impacts, then Ansys LS-DYNA is a go-through product for you. Ansys Forming is a very recent last year acquired module which is being useful for the sheet metal forming applications. So those who are being interested in Industry 4.0, for them this module will be very helpful. Ansys Motion is being required in I think 2019 onwards. So previously Ansys do have a product called Rigid Motion. So that module is only be utilized for simulating the rigid bodies. So if you are interested in knowing the motion of rigid bodies, so you can utilize the rigid body dynamics module. But now with the recent advancement, there is been a need to know what is being the effect of the rotating bodies onto the non-rigid bodies. What will be the deformation or what will be the stresses happening onto the structures which are not rigid. So Ansys Motion do provide you those facility where you can simulate the rigid bodies along with the flexible bodies. So those kinds of complex simulations can be performed using Ansys Motion. Then Ansys Sherlock is being another module which is being utilized for predicting the life of the electronic component. Okay, and which are dedicated for the electronic life cycle of the electronic component at a chip level specifically. Okay, then there is another module called additive solution. So additive solution, I have already told you, those who are being interested on working onto the metal 3D printers part. For them, simulating the metal 3D printer phenomena layer by layer, how it is been printing, what will be the deformation, what will be the stresses, how the printed part will be print with the different supports, what will be the distortion happening onto it, how we can build the component faster. So all those kinds of simulations can be performed using Ansys additive solution. Then encode design life is a module which is being utilized as per the industry code for the fatigue analysis part. Ansys do have Ansys fatigue module into it, but Ansys encode is a dedicated module designed for the industry ISO codes, which is being required to go pass through the fatigue analysis part. So if you are interested in finding out the fatigue analysis as per the codes, industry codes, then ENCODE will be the module for it. And lastly, there is the Autodyne, which is again the explicit solution from the Ansys side. Apart from Ansys LS-DYNA. LS-DYNA and Autodyne, both are the explicit solver. But what is the major difference is the application. As I already told you, LS-DYNA is being used for the impact analysis or a crash analysis. But Autodyne will be utilized for the blast analysis. So majorly all the defense laboratories like DRDO, where they are being interested on working onto the blast of a missile. If they are releasing a payload or a missile from an aircraft and it comes and impact with the earth, so what will happen? So how much the impact will be? What will be the soil structure interaction part? So all those kinds of applications can be performed with the Ansys Autodyne. So these are the few applications where structures can be utilized as of finding out the strength analysis, vibration analysis, additive manufacturing analysis, composite materials. Then you can see durability, rigid motion, then fatigue life, Autodyne part, and then lastly is the Ansys LS Dyna, where the crash testing and impacting, and even very recently one interesting paper has been published. What will happen to the ball while playing the cricket? What will happen to the ball when it is being under the contact at a different location of the bat? So that kinds of analysis is been recently conducted using the Ansys itself. So you can see these days we are been looking into the cricket match itself, that ball getting older, even though at a 40 overs and 50 overs itself, even though the new ball will be given at a 60 or 70 overs. So those kinds of evaluations is being starting to be working with the applications of Ansys and all those things under the impact analysis part. Then you can see the different applications like harmonic analysis. This has been the harmonic analysis of bridge, if you can see it here. Okay, how this suspended bridge will be behaving when there will be very high wind is been blowing. Then non-linear structural analysis, kinematic analysis, crash analysis, durability and fatigue analysis part, composite material part, which has been important. So dedicated module has been there, Ansys ACP, those who are working into the composite side. So to find out what are the failures into the composite part, which particular layer is been failing. Okay, so whether we need to increase the thickness of those particular layer, or the orientations can be changed. So those types of analysis can be performed using Ansys composite. Then if we are talking about the structural parts, we need to include the civil applications as well. So you can see the dynamic analysis of model or the seismic analysis part, which has been very important into the civil applications, can be performed using Ansys mechanical. Structural design and stability, internal component, what we are been designing into designing our new houses, people. So architectures are been utilizing the Ansys code to find out, to minimize the material, to minimize the size, what will be the effect of the particular component when it is being utilized into the day-to-day activities. Okay, then buckling simulation with the linear and non-linear applications part, transportation engineering, selection of the material, models of a big structure. So whatsoever structures are being created, it requires the stress part. So what will be the strength of that particular structures will be. So that can be analyzed. Then seismic analysis of the huge towers. Then fire behavior. So the fire vents are being there. With a high intensity of fire, what will be happening to the structures part? Those can be analyzed. Then the design against the wind loading, how the wind loading will be affecting our the big structures which has been constructed under the civil constructions part. And lastly, you can see the blast explosion. And this is again been a classic examples of this reinforcement a concrete structure where aircraft has been hitting the into the building. This has been the analysis of Burj Khalifa which Ansys has been performed. Before developing a Burj Khalifa, they have done the impact analysis using the aircraft, because they don't wanted to repeat the same thing which has been happened onto the World Trade Center. So if any aircraft attack has been happened, so what will be the scenario, whether that amount of impact a building can sustain, so that it will withstand a minimum losses. So that kind of analysis has been performed onto these big sort of buildings. Then this has been an example of impact analysis. You can see the complete structure of vehicle is been utilized to see the crash analysis of a complete body. This is the frontal impact, this is the side impact, again a frontal impact. So the last one is the Toyota model, which has been conducted over it. So as to this crash analysis only will gives us an idea if the frontal impact happen, what will be the impact onto the driver and the passengers which are been sitting onto the back seats, whether how much it will impact when the seat belt is not been there, how much the impact will be, how much will be the damage to the cars as well as to the passengers, those who are been sitting into the cars. And this Tata Nexon is being completely built up onto the Ansys platform, where they could able to achieve the 5 rating with Ansys simulation part. So they are our prime customers, and even the electric vehicle which has been a new car which is about to release is completely been modeled with using the Ansys simulation part. Now if we talk about the fluids, so again under the fluid product line there are a lot of products which are being available. So the first one is the Ansys Fluent, which is the gold standard tool for simulating the internal flows, external flows, finding out the aerodynamic pressures, aerodynamic forces onto the structures where the fluid is being involved. Then and it is irrespective of any of the geometry. You can utilize it for any of the geometry into the fluent part. Then CFX is a tool which is dedicatedly being used for the turbo machineries. If you are being simulating any pump, any fan, turbo machineries part, so you need to work it on into the Ansys CFX. Okay. Then Chemkin Pro is another module or another tool which is being utilized for simulating the reactive flows, where the chemical reactions of fluids are being taking into the place. For those things, chemical reactions are being involved. Then you need to utilize the Chemkin Pro, which is majorly being used into the this chemical engineering part. Okay. Then Ansys Forte has been there. Previously, Ansys IC engine module was there, which has been replaced with the Ansys Forte. So this module is dedicatedly being used for the IC engine simulations, where you can look into how the valves are being opening, when the compression happens, when the fuel is being injected, fuel air ratio is being injected, what will be the ignition of it, how the exhaust gases are being passing on from the valve side. So, and during that part, what are the pressures, what will be the deformation, and all those things can be performed related to the IC engine parts. Then Polyflow is been a tool which is being utilized for the highly viscous flow materials. So basically for the molding processes, what are being which requires a highly viscous fluids to be utilized. So for that kind of applications, Polyflow module tool can be utilized. Then FencePiles is a dedicated module which can be used for finding out the phenomena of icing and de-icing onto the structures, and it is dedicatedly being used at aircraft industries. When aircraft flies at a high altitude, the temperature goes to the -degree temperature, where the formulation of ice is a normal phenomena. When the formulation of ice is been happening onto the wind side, all the control devices are at a wind, where the ailerons and our control devices will be there. How much it will affect our control devices performance, we can simulate using FencePiles module. And lastly is a Rocky. So Ansys Rocky is the latest acquired module. Those who are been working on a discrete element modeling, where you are being interested in finding out what is being one particular discrete element. At one particular element, you wanted to track where it is being going, how it is being following, under what circumstance it is being coming it up. So you can track each and every discrete element, and you can model the complete system. So the best example is for the Rocky will be under the mining situations where you can see the coals has been digged up and piling it up outside. So what will be one coal positions when it is been piling it up, okay? Then in agriculture applications, if you wanted to simulate how the wheat grains are been coming into the machine or a wheat paddy is been coming into it, how the dust and the wheat is been segregated part. So you can track each and every grain of the wheat, and you can see how it will be processed into the machinery part. Mixing it up into the pharma industries, mixing it up the chemicals, the grains of the medicines. So you can track all those things, how it will be featuring it up. So that can be done by the Rocky DM tool. Then if we look into the computational fluid dynamics part application, the first one is the turbo machinery, compressors, IC engines. You can see the wall has been opening, then air fuel ratio mixture has been entering. Now again the compression will be taking place. Then after the compression again it will expand and the exhaust gas will go out. Then this has been an example of two-phase heat and mass transfer. You can see that two different phases are been there. Now heat is been passed on to it, how the phase has been changed. Then second last is the heat transfer one, how the heat exchanger, the heat is been flowing from the fin sides. And lastly is the rotor and the propeller. If you see the application into the civil side, so you can see the first one above one is the external aerodynamics, digging up of tunnel. So into the tunnel, how the wind will be there, what will be the air pressure into it. So this comes under the a civil area, but the analysis will be a CFD side only. Then designing up underground stations, a metro station which are being designed underground. So there what will be the ventilation, how the ventilation will be processed. So those kind of air ventilation, HVAC analysis can be done. Then fire simulation, that is been again a very challenging part. If the fire happen at particular location, how the fire will be traveling into the station part, what will be the safer side for the people to be evacuated. So all those kinds of things we cannot imagine while constructing. Okay, if the fire will come this side, people will run away that side. If the fire will come this side, or we should have a common area of evacuation. So all those things will come under the picture when we do the simulation part. Okay, so smoke detection. So recently onto the industries, it has been implemented when, especially into the Punjab and Haryana side, that detecting a smoke, how much smoke is been coming from the Haryana and Punjab side to the Delhi, because the lot of pollutions, these things has been coming into the picture from last 4 to 5 years into the Delhi side during the winter time. So they need to track it on where the smoke has been coming. If at all it is more intensified, they need to change the location of their chimneys and all those things. They need to implement more filters into the chimney side. So all those things are being done and utilized by using the simulation tools. Then if you talk about the chemical applications, you can see the heat exchanger, the walls, particular flow, fermenter, distillation column, NOx burner, all those things where the chemical reactions will play a major role can be simulated by using the Ansys Fluent and Chemkin Pro module. Then I will quickly take it through the high frequency products, also the electromagnetic side. So I think most of you are from the mechanical domain, but these all products are being useful when you are being dealing with the multiphysics applications. So just to give you the brief part, so Ansys HFSS has been a tool which is being utilized for designing the antennas. So those who are being interested in working out, designing an antenna and work on to the structural part of antenna, for them they can start with the structural analysis with the HFSS side. Okay, then SI wave is been a module which is being utilized for learning or knowing the EMI EMC analysis of the interaction between the different antennas, what is being there onto the different onto the ICs. There are different antennas are being placed, how those two antennas magnetic waves will be interfacing each other. So those kind of simulations can be done. Then this iSpec is a major tool which can be utilized into the mechanical applications as well. Those who are being interested in knowing the thermal analysis of electronics devices, the heating analysis onto the electronics application, Ansys iSpec is been module for knowing it. The basic physics behind the iSpecs is the CFD only. Then Q3D extractor is been a module when onto the ICs. There are a lot of components are being placed. How they will replicate it with. So onto the ICs, there are a lot of resistance, capacitors, inductance are being placed. So how do they perform? How do they will be implemented into the complete IC part can be solved using Q3D extractor. Then EMA 3D cable and charge. Two new modules which are being added into the HFSS module is this cable is being a module for again finding out the EMI EMC under the cable itself. Now you can see there are a common cable is been coming under which there are a lot of wires into it. So each wire having the different connections over it. Whether those connections are being interfering with each other or not, we can analyze due to through this EMI 3D cable. And charge part, if you are been working onto the battery, how the battery is been charging, how it is been uncharged, whether it is been overcharged or not. So those kinds of things can be done with the using EMI 3D charge. And NSUT filter is been a dedicated module which is being utilized for designing out the filters for electromagnetics. And the example for it is signal and power integrity, which can be done by the SI wave. The autonomy, in the autonomy, the major role is of antennas only. So how the antennas are being placed and they are getting the response from the different applications which are being coming outside. So that ADAS part can be performed, then filters, then in aircraft itself, there are a lot of antennas and microwave sensors are being kept it. How do they are being performing? How we can find out the radio frequencies of all those sensors into the aircraft planes can be done. Then second last one, you can see the very normal applications of a smartphone. In smartphones itself, there are a lot of sensors are being placed, antennas are being placed. So what will be the optimal position so that it cannot harm the person, as well as it will not interfere with the signals. You should get the proper signals into your mobile phones. It should not interfere with any of the biomedical applications part, either it is with our skin or with the other devices. So those kinds of simulations can be performed. And lastly is the placement of antennas onto the vehicle. At which particular location we should place the antenna which can be provide the maximum outreach to it. In low frequency part, we do have the Ansys Maxwell, through which you can design the complete motor. So electric vehicle, those who are being interested in electric vehicle, a motor is a major component which you can design it with the Ansys Maxwell part. So Ansys Maxwell will not limit you to design the existing motor itself. You can design any new motor as of what you are been thinking it of. And Q3D extractor is the same what is been there in a HF part. Simplorer is a new module which is being utilized for linking up the motor or a battery with the existing circuits around it. So let's suppose there is a battery or a motor in an electric vehicle. Motor is having its own function, battery is having its own function. But once you wanted to look into the complete application where the motor will get a power from the battery and how the motor will be giving the output to the vehicle. So this is the complete system, how it will work. That complete system level of working can be performed into the Simplorer itself. Then iSpec is again the module for the electronic cooling. MotorCAD has been a tool which is being utilized by the industry where the predefined motor template has been there. Okay, so once you select any template, based upon that template, a motor will be designed. So you only need to provide the input, the parameters, and based on those parameters, your motor can be developed. But whereas in a Maxwell, you have to design your own motor completely, okay, irrespective of design. And lastly is the NSUT filters. Again, the filters need to be designed for the low frequency as well as for the high frequency. Both can be done by the NSUT filter. So the application will be the electric machine motor efficiency graph. You can model a transformer. You can develop a wireless chargers. These days, lot of wireless chargers are been coming. Then eddy current, like flaw detection or throttle positioning, both can be judged for the motor part. Then IGBT, development of the MOSFET, all those things can be done. And then you can go for the complete motor design, solenoidal valve, transformer, microchip, waveguide, antennas, all those things can be developed. Now we come to the next topic, which is the multi-physics application. We talk about a lot of things. Structure products we have the fluids, we have the electronics, we have the electrical component. But as in a first slide itself, I have told you Ansys is a multi-physics module. So how do these multi-physics applications work? So for the multi-physics part, so when we are dealing with more than one physics, so we require the data to be transferred from one physics to the another physics. The one way of multi-physics will be this, transferring the data. The second way is the one-way coupling. We solve the one physics and we put the solution to the second physics. And lastly is the two-way coupling. So what will be the two-way coupling? We solve the one physics, we take the output of first physics as an input to the another physics. Based upon that, we solve our solution. The output of second physics goes as an input to the first physics. Okay, so it will become a complete change cycle. So it is a two-way of analysis part. So now we can see how this all the three ways can be utilized in into the Ansys part. So if I talk about the data mapping, so how do we can implement the data mapping? The first one is, let's suppose you have any component, you have done the physical testing, you have the data. You can take out that data into the Excel sheet, copy it into the Ansys, and those data can be implemented onto the simulation directly. So through that, a data mapping can be done. Okay. Then the second one is third-party module. Third-party module is those data which you have been taken, you can take it to the third-party tool, irrespective of any tool. Okay, you can do those simulation there. That data, if you wanted to call, you can take it as an external data, and that data can be called into the Ansys, and Ansys will accept it and take it as an input, and based upon that, you can do the solution. Okay. Now, how those data and this meshing can be performed, meshing can be changed. So look into the fluid and structural mesh. So as those who have been working onto the fluid side, they know that at the boundary level, they require a very fine meshing. But whereas into the structural, it doesn't require a very fine mesh. So how do we implement the meshing from one physics to the another physics part? You can see those data mapping into between. The fluid part is having the very fine mesh in between, but whereas the structural mesh, it is very structured. Okay, so wherever the mesh is been coincide, the directly data is been transferred. But whereas in between there are more mesh number or mesh count is been there into the Ansys. The data has been split into it, and half the data goes to the structural upper one and half will go to the lower one side, so that the complete data need to be transferred to the structural side. Through this particular phenomena itself, the complete data, either it can be a data mapping or a one-way coupling or a two-way coupling, it will be transferred to the different physics side. This is how the meshing can be done. So now if we take about the example of one-way analysis, one-way coupling, so you can imagine there is one prop, okay, which is being subjected to the high pressure flow. Due to that, there is a vibration onto it. So if we wanted to calculate the vibration, very simple. Onto the structural side, we can take this particular this prop and we can provide the natural frequency, and based upon that we can find out the vibration over it. But whether it will be a realistic, no. So for finding out the realistic, what we need to do is, we first create this prop, we put up into the fluid flow. Based upon that fluid flow, it will experience some pressure, forces. Based upon those forces, we calculate what are the vibrations this probe is being induced. Okay, so what will be the procedure? We will start with the fluid. Okay, fluid flow. From fluid flow, we could able to find out the pressure as the output. Those pressure or the forces is been given as an input to the structural part. Based upon those input, we come to a conclusion of vibration, and we stop the analysis. So this is a one-way coupling, where output of the fluid goes as an input to the structures, and we find out the solution. Okay. Now if we talk about the two-way FSI. Okay. So if we talk about the two-way FSI, let's suppose we take an example of that particular flap. Okay. What will happen? So initially that flap is standing at a straight. So when we put up into the fluid flow, what will happen? The fluid will come, okay, it will impact, or you can, let's suppose you can take the example of this particular mic. Okay, initially the wind is flowing onto it. What will happen? It will deflect it. Okay, so due to that deflection, what will happen? The pressure will be exerting onto that initial phase. Force is being induced. Due to that force goes into the structural side. Due to that induced force, it will deflect it to this place. Yes. So now this new deflected shape goes as an input to the fluid again, goes back. Then based upon that deflected shape, again the fluid flow will be changed. Due to that fluid flow change, the pressure will got reduced. Okay, new pressure profile will be created. Due to that new pressure profile, again it will be tilted. Yes. So now the new shape is been attained. Now again that new shape goes to the fluid part. Again the new pressure profile will be coming. So this has been a constant phenomena from where until the pressure profile or the forces become zero. Initially when it is being straight, the pressure will be maximum. When slowly it is being tilted, the pressure profile will be zero. So until or unless the pressure which is being attaining onto that flap is not zero, that loop will be goes on. So that is what is a two-way coupling, when the physics and the structural physics, CFD and the structural physics are being constantly coordinating with each other. So we call it as a two-way coupling. And the classic example is a Tetra Pak. So whenever into the Tetra Pak, we are being pouring out our milk or any of the juice over it. What will happen? When the fluids come out, it will blup it, expand it, and again goes in. So what will happen? Due to that pressure, the structure goes out. Then due to that pressure, again it will force the pressure into inwards, due to which again the fluid will come out. So that is what the red portion is been blipping up. So due to that fluid, what is been happening onto the structure, again due to that particular structure, the pressure is been exerted and the fluid is been coming out. Again due to that cavity, what will happen to the structural part? So this process has been repeating until all the fluid comes out. Okay, so that is been an example of two-way coupling. And the classic example of two-way coupling is the oscillating plate, which has been verified from one of the research journal. So you can see the flapping result, which has been experimentally conducted in year 2001. So utilizing the Ansys Fluent and CFX, both module, you can see the exact result has been matching it out. What is been we are been getting it with the experimental result. Now for a multiphysics, you can see with the different physics part, how we can say a multiphysics part. If the fluid and structure problem is been addressed, then it will be a fluid structure problem. Okay, if you are been working it on noise vibration harness, so structures and electronics problem will be clubbed. If you are being interested in chip packaging problem, so it will require fluid structure electronics as well as semiconductor problem. If you are being interested in electrothermal cooling, so it will require structural fluids and electronics modules to be clubbed. So this will be giving you an idea about how the multiphysics problem can be judged, and I will showcase you one of the case studies which we have done it for the motor side. So you can see we started with the low frequency product Ansys Maxwell, where we model a motor. For that particular motor, we find out the Lorentz forces, what are the forces are been coming. Those forces, we have given it to the complete model of, structural model of motor. Due to those forces, what are the vibrations which are been coming? Those vibrations we have calculated in terms of frequency. Those frequency we have given it to the acoustic module, where we calculated the waterfall diagram. Okay, based upon that waterfall diagram into the Ansys sound module, we have find out what is been the noise of the motor. Whether it is been coming or not, I need to check. Yes, now it is been coming. You can see as the RPM is been increased, the noise of the motor is been increasing. So this has been the classic example where the multiphysics has been utilized, starting from designing of motor, taking it to the structural part, and then to the acoustic module for finding out the noise of a motor. Okay, then this has been a classic example which we are been looking it for, or we are been teaching to our students of the flow over to the sphere. Okay, where what will be the boundary conditions, whether it is a laminar or a turbulent flow. So these kinds of graphs are being available into the books. But what if we implement the simulation into our curriculum part? If we could able to showcase these kinds of simulation to the students, whether it will be helpful for them to understand, okay, how the wakes are being created, what are the regions where the negative pressure is being created. So what will be the laminar, what will be the turbulent flow when the Reynolds numbers are being increased. So those kinds of studies can be implemented by using the Ansys part. And for multiphysics application, you can see there are other applications which I have kept it, explicit analysis, thermal analysis. This second picture is the laptop picture, where how the fans is being utilized for extracting the heat out of the laptops. Then offshore structures, heat exchangers, dam brake, wind load, all these are the classic examples for the multiphysics part. Then you can see the bridge design, industrial smoke, tracking smoke emulsion, then HVAC analysis, designing of what will be the ideal position of putting up the air vent for AC, whether it requires a 5 AC in a room or require 2 ACs in a room to provide a proper cooling. So those kinds of simulations can be done. And then lastly is the seismic analysis or a small soil structure interaction of a blast analysis part. Then these all are the biomedical applications. So you can imagine how dedicated is or a delicacy is been required to handle the biomedical applications. But Ansys do provide a solution into those fields as well. Then if I talk about the case study of the multiphysics part, so you might have heard the name of Lucid Motor. Those who are been providing or developing the luxurious electric vehicle for their customers. So they utilize Ansys multiphysics tool for development of complete electric vehicle design, and they have given us an input using the Ansys multiphysics module. They could able to achieve a 12% increase of the motor efficiency. So you can think over where the motor is a major tool for increasing the efficiency of the vehicle. So they could able to increase 12% of it. So that is a very big achievement for any of the automobile industries right away for increasing the motor efficiency by 12%. So that is what the value is being added by the Ansys into development of any of the product. So if I talk about the technological labs, so Ansys do provide a complete solution to all the engineering domain, starting from mechanical, automobile, civil, aeronautical, chemical, physics, electrical, biomedical, in all the domains of the engineering right away. So if we talks about the technological labs, the advancement which is being going on into the industry sites. So in terms of high value engagements into the Ansys as well as into the curriculum part, this has been the need of engineering era into the engineering institutes, where we need to look over the classic studies which are being going on into our curriculum by implementing the new courses into our curriculum part, starting from the electric vehicle part, where Ansys do provide a complete end-to-end solution to for development of the complete electric vehicle, starting from electric machines, battery, control, power electronics, system engineering, functionality, safety. All these modules are being available into the Ansys right away. Then if you talk about 5G, so which is been booming right now with all the 5G towers, every telecommunication network people are been installing their 5G networks. Even though we are telling it as a 5G, already 6G implementation and testing is already been started by the Ansys. But still we are taking it as a 5G part. So complete 5G lab can be set up starting from the level of chip, packaging system, signal and power integrity, optical and integrity analysis, antenna design, RFI, EMI, EMC cable analysis, complete electrical environment, and the multiphysics part of the 5G systems can be simulated. If we talk about the healthcare, you can see the medical devices, pharma and biopharma, COVID-19 particular supports, what is being worked out from the Ansys side. We do provide a solution to all these dedicated healthcare industries part. So if you talk about the COVID-19 dedicatedly, you can see during the pandemic, Ansys do provide a support along with the prime institutes of India, like IIT Ropar. We provide the simulation of negative pressure room through which they could able to design a negative pressure rooms for the COVID patients. Then with IIT Bombay, we could able to develop a mobile booth for providing a proper testing of the COVID positive patients without medical officers to be infected from the COVID part. Then with IIT Kanpur, we could able to design the low-cost ventilators into the second waves when there is a huge requirement of ventilators is being required. So we do, with the Ansys IIT Kanpur startup, we could able to achieve this milestone by creating a low-cost ventilator as well as the oxygen concentrator also. Then we have done the mask analysis, whether how the mask has been important for to get unaffected from the COVID-19, those kinds of simulation, and how do we need to provide the inhalers for those kinds of support is being done by the Ansys into the pandemic. Then if we talk about the smart manufacturing, you can see the metal casting, metal forming, metal removal, joining, finishing, additive manufacturing part, all those kinds of solutions are being already provided by the Ansys for setting up these technological labs. Then as I have told you, for the ADAS, we do have the complete solution for the ADAS vehicle, starting from the testing strategies, world modeling, so different obstacle, different scenarios can be providing through the scenario generation, adverse weather phenomena, whether it is extreme hot, extreme cold, snowy, rainy, those kinds of weather simulations can be done. Then driver in loop simulation part, scenarios, keep it into the loop for extracting the data. So all those kinds of analysis can be done with the ADAS module. Lastly, we have kept it a UAV part, which has been very recently comes into the trend with the lot of UAVs are being modeled, people are been working on drones. So Ansys do have the end-to-end solution for development of complete drones, because in drones itself, there are been a motors, there are been a battery, there are been a rotating devices. So all those things can be simulated by Ansys itself, starting from the aerodynamics, airframe, aeroelasticity, control system, communications of antenna, designing of the complete camera. So all those things can be done by the Ansys. Apart from it, there are a lot of robotics labs been there. Advanced FEA, advanced CFD labs has been there. So a lot of technological labs can be set up by using the Ansys module. So if we goes on into the Center of Excellence program, or we are looking at setup of any of these technological labs, so what will be the major objective, or I can say motivation for the institutes for setting up of these types of technological labs? The first one will be the overall institute development. So the name and fame of the institute will be goes up, where it can be emphasized on that this particular institute is having the world-class facilities of providing these kinds of courses which are being available. Then due to this, the complete development of smart engineers can be done. So with those Center of Excellence students, those who are working on these advanced technologies which are being required into the industries, obviously those smart engineers will get a priority from the other engineers which are being coming out from the normal curriculum part. Then update of student for the research part. These days we have seen there is a very lack of research which is being going on. After the BTech students wanted to go into the directly into the job segment. So there is a very downfall onto the research part. So these centers of excellence, these technological labs will boost up the interest into the research with the new and emerging technologies which we are being going on. Through these technological labs, students can get motivated into the research part, moving ahead with the new innovative things which has been coming out of these labs. And then these Center of Excellence will be the useful for collaborate with the industry and academia. These latest or the technological labs are not the normal labs. These are the lab standards which are being done, or these all are the modules or a testing which is being done by the industry itself. So it will be a very good collaboration with the industry and academia part, where the student, those who are being trained under these programs, can directly be absorbed into the academia through this COE's program. And lastly, and which is a very important, the student profile development. So those students working on these advanced labs, advanced modules, definitely their profiles will be increased. They do not require to go into the market and sell them. Industry will come to them and they will ask for the collaboration into their research and development activities in their organization itself. So that is been the brand which has been this COEs programs can create under the environmental part. And what will be the whole soul activities which can be performed using this COE model part. So it can be the centrally hubbed activities which can be performed. So apart from the research and development, where we do write the research proposal, or the MTech and PhD students can be guided where they are writing the research articles onto this. They can perform the consultancy work. For students, they can perform their mini and major projects onto these latest applications part. They can do the internship activities. Students, those who are being motivated, they can start their incubation or startup programs based upon these new technologies into the institute itself. Likewise, if you can see in IITs, lot of IITs are been giving a space to their students itself for starting up their startups. They fund them for creating the entrepreneur into their segment itself. And lastly, due to these kinds of model engagement, academia, industry will be comes into the contact with the academia, so the collaboration part can be done. So that has been the most attractive part. And this has been the COE model where the scope of work, what the Ansys will be performing, what ARK will be performing, and what the institute will be performing. So that has been there. Then in terms of incubation and the startup programs, so what will be the major deliverables? So under those part, the live industrial projects will be given to the students. The project which is being going on to the industry, we will take those projects and give it to the student itself, so that they will get an idea what the projects industries are been handling right now. So to give them a field exposure of it. Then industry academia collaboration onto the project part. Directly the project which are being handled by the industry, they can give it to the students, so that student will get benefited and their projects can be done onto the same project what industries has been working it out. And their student innovations, their major and minor projects will be completed through this incubation program itself, and which will be useful for the institute as well, for the NBA and the NAC accreditation and all those things which has been required for the recognition from the government side itself. And the major part is the curriculum development. So these technological labs will enhance the curriculum as per the industry standards which has been required right now. Okay, so the detailed syllabus as per what is being going on, we can implement the Ansys into the curriculum part, which will be benefited for the student to learn the new things as per the industry segments, or what the industry has been working it out. Then these tools, Ansys, dedicatedly Ansys, if I talk, which has been utilized in industry, will help to get the internship and the placement to the students as well. So when the industry will be looking it out for the students, those who are being well trained, so dedicatedly to that, they will directly jump into those COEs where Ansys have been set up, and they will be doing the mass recruitment from there itself. So it will be benefited for the student as well. And these are the few benefits what the Ansys provides to the students and to the institute, which I have already been discussed about what will be the curriculum part, doing the projects and doing the live projects, then getting the NB accreditation and all those things. So implementations will be getting the skill development program, knowledge assessment, real life experience onto the life projects, and the career opportunities if those kinds of technological labs can be implemented in any of the institute part. So those programs can be tracked using the portal which we in-house we have developed, through which the students can sign up into it. Their profiles is being created, and day-to-day activities can be tracked on. How much work they have done, how much assignments they have done. So all the tracking part can also be done. So it is not nowhere like the program has been on, students are been working or not, we don't know about it. But we do have the complete automation part for tracking up the each and every student profile, what the students are been doing. So through this this portal, you can able to find out what will be the requirement, what is been the assessment the student has been done. So day-to-day training, what all those things can be implemented, everything can be tracked. So what will be the major outcome of these technological labs if it has been implemented is the industry-ready professional, which will enhance the employability, then exposure to the advanced technologies, and lastly, the certification. So, which is very important. Whenever you go and sell yourself to the industry, that certification will talk a lot about it. So, those things will be the major outcome which will come out from these programs. And these are the simple courses which we can develop with all this technology. If we talk about 5G, let's suppose. So these all are the courses starting from 2 weeks to 6 months, 1 year. Different certification programs can be launched by the institute for their own students as well as for the outside students. So that has been a kind of model we can approach it into it. So now we are reaching towards the last segment, which is right now till this point we have been talking a lot about what has been can be done by the Ansys. But the major part is from where we can learn this Ansys. Okay, the lot of applications I have told, lot of tool modules. Yes, ma'am. Yeah. So for that, you can see if we start with the learning path, you can see there is the first is concept. You need to know the concept behind it. As PM Pandey sir has told, don't blindly follow the simulation. Don't blindly follow the tool, what you have been working. You should know the concept. For developing that concept, Ansys have launched their own AIC courses, Ansys Innovation courses, which are the free courses available onto the Ansys Innovation Hub. So physics-based module, physics-based learning can be done through AIC. Once the concept has been developed, you can now jump into the second phase, that is the simulation, where you can start working onto the tool. Okay, so starting for working onto the tool, you have the AIC premium courses, which is the paid courses, Ansys Learning Hub. Ansys Learning Hub is another paid subscription platform where you can find out all the tutorials, all the video lectures related to the all modules which I have showcased before. And lastly is the Ansys student products. So freeware Ansys product has been available, which is can only be utilized for learning the tool, not for publication, not for conference publication, nothing else. Okay. Once you have learned the simulation, while learning the simulation, you might face some problem in getting out the solution. You might know why I am stuck somewhere in a simulation. So you can definitely go to the learning forum, where Ansys person will give you the guidance to solve your problem, or even though you can directly call ARK and Ansys team for solving out your, giving out the solution to your problem. And lastly is the certification, which is a very important part. So you have learned Ansys, but you wanted to recognize yourself into the market, that I know Ansys, I knew the concept of Ansys. So for that, a certification courses are being there, which can be taken through the AICs. Okay, so this is the Ansys Innovation courses which I am telling you. Almost 300 plus courses is been designed by the industry and the academia. So those who wanted to learn the concept, please go and visit to the ansys.com/courses. You can learn about the concept of the courses there. So you can watch it, you can practice it, and you can assess it through online portal itself. So this initiative comes for all the physics. It not for a mechanical, not for the electronics. Even all the segments of courses are being available, and it is free of cost. Learning is free of cost. Okay. Now, in Ansys Learning Hub, which I have already told you, it is like a Bible for Ansys, where all the video lectures are being recorded and kept it there. All the tutorials are being kept it. Live classrooms are being available there. Then virtual classes are being available there. So it is a paid subscription, which is need to be taken. Earlier, I think so, NSUT has already taken it. The access of this Ansys Learning Hub, where you can see the campus building is being designed. Each campus building is having a different module. Into that different module, different learning path is been there. Through that, you can learn all the physics, irrespective of any of the physics. All the contents will be available into the Ansys Learning Hub itself. Now, very last, only 2 minutes I will take. So lastly, I will tell you about the certification courses, which is very important. So till this point, I have told you the learning is free of cost into the Ansys certification, Ansys AIC courses. But once the learning has been done, if you wanted to get the recognition that yes, I have learned anything, now I wanted to get a badge or a certification. So you can attain those batches or certification through AIC courses. So there are 3 different certification courses are being available. The first is associate certification, professional certification, and expert certification. Okay, all these 3 certifications can be achieved by attaining the exam or by clearing the exams of AIC, but again it is a paid one. And there is a digital batches also which are being available. Once you complete any batches, you can attain those part. So we have list out the list of batches into the bundle. Like for the structural, FEA theory mandatory is a mandatory where you can learn about the theory of FEA. That is again a free of cost. And out of these, all 5, any of the batches can be attained. Like the stress analysis, material analysis, dynamics, optimization, or getting started with Ansys mechanical. All these courses itself having 3 batches with it. Okay. Then similarly for fluids, similarly for the electronics. Whatsoever batches you want to take, you can attain it from this particular courses. This has been a customized implementation plan for each courses. So it is again a customizable depending upon the requirement. So for attaining Ansys certification courses, either it can be a 90 hours, either it can be a 60 hours. So it will be having the hands-on training, it will be having a theoretical classes as well as the online learning of AIC courses. So if I talk about the courses as per the certification courses, 1 minute, ma'am. So certification courses, you can see 4 structural courses, 2 CFD, and 1 electronics courses are already been launched for the certification part. And for batches, you can see almost 300 plus batches courses are already been floated. So those who are being interested in associate certificate, you can see these are the different certification courses which are being available onto the AIC websites. If we talk about the Ansys multi-physics part, if you wanted to attain the physics of structural mechanics, you need to cover these 8 courses. Okay, once you complete the 8 courses, each courses have the lesson modules like this. Each courses will be of approximately 1 hour. So 8 hours will be required, a complete dedicated with the quiz and all those things. Once you attend all these courses, each courses is having the each batch. Okay, so either you want each batch will be there. If you wanted to have all the courses complete, once you complete all the courses, you will attend the 1 certification, complete certification part. So similarly, this has been the workflow for the batch, what is been there for the certification part. This has been a learning track which has been there. So there are different learning tracks also available into the AICs. And the last information which I wanted to give is each batch is of 1200 rupees. Okay, and each associate certification is of near about 22,000. Okay, it is quite expensive, but yes, if the count comes to us directly from the NSUT side, then it will be the discounted, as NSUT is a prime customer of us. So if anyone is interested, please contact to Abhishek sir. He will link us for you for this certification part, certification and this digital batches. So again, I am repeating, digital batches is of 1200 rupees of each course, which can directly be linked to your LinkedIn, Facebook, and all those things. Okay, so this is all from my side. Thank you. Anything you wanted to know? Any question? Any doubt? Anything? So please reach out to me. Even though if I am not available, you can contact to Abhishek sir. He will give my details so that you can reach out to me in terms of any help related to the Ansys part. Okay. Thank you very much.
Thank you so much, sir. Now I would request to Dr. Vivek Kumar to present a token of respect to sir. Thank you so much, sir. The next session will be started at 1:50 by Professor Kulak Mohan Pandey, sir. So be available here right now also. Okay. At 1:50 p.m. Thank you.
बजे वाला उसका ज़्यादा इम्पोर्टेंट है, ये तो चलो कोई नहीं, वो तो बहुत इम्पोर्टेंट है। उसका लाइव नहीं हुआ तो बस कुछ नहीं हुआ। हाँ 2 बजे आना, जो IIT से आए हैं ना वो देंगे।
ये नकली वाला था, अब ये असली वाला
नकली
होगा।
वाला था।
ये तो पहले भी हुआ था, फर्स्ट डे भी सेम ही तो हुआ था।
क्या करें, जो बोला जाएगा। कोई नहीं रुक रहा।
कौन रुक रहा है? क्यों?
expert lecture will be delivered by Professor P.M. Pandey, and the topic will be ECSM process, micro drilling applications, and finite element analysis. Over to you, sir.
Okay, so thank you very much. So as this course is dedicated for finite element analysis, so let us try to see that how this finite element analysis has been used for a manufacturing application. So I'll be a bit brief because I'll finish by 3. So okay, so I'm not going to talk about all these things. We all know about the various engineering materials, and we all know that we have materials with stringent properties, correct? And it is not easy to shape the materials. So time to time there have been developments and number of processes have been developed. Like some examples are typical materials which are used in various industries like aircrafts, aerospace, medical, electronics, and also for tools and dies like sintered silicon carbide, aluminum alloys, different kinds of ceramics, Kevlar fiber composites, etc., etc., Pyrex glass, soda lime glass. So if you want to really machine those materials, there's a lot of challenge before the engineers. So we all know that there are different issues which relates to say high precision, different geometries, complex shapes, surface quality, thermal, that is heat affected zones. These are the problems. So people have tried for this non-conventional machining processes, which are also termed as advanced machining processes. So we all know that there are a series of processes which involve variety of energy, which starts with the mechanical energy with the mechanism of erosion or abrasion, chemical dissolution, we have processes like chemical milling or chemical etching, and then the two very popular processes which we all know, that is electrochemical machining, ECM, and electric discharge machining, which is EDM, which is based on the electrochemical dissolution, and the thermal energy based processes which involve melting and evaporation as the mechanism for material removal in case of EDM process respectively. So here there's another process, like we all know that the basic limitation of ECM and EDM process, though they are quite versatile and they are widely used in industries, however, you'll find that there are limitations in terms of that conducting material only they can be machined. If you want to machine a material which is not a conductor of electricity, you cannot do that in both the processes, whether it is ECM or EDM. So what people have tried to do, that a factor which is actually detrimental in case of electrochemical machining, that has been used to machine a bad conducting material. Now, in case of electrochemical machining, we all know that there's a hydrogen bubble formation, or there's a hydrogen that gets evolved when there's a reaction, and this hydrogen is liberated from the, I believe it is liberated from the cathode, and you will find that this cathode is also polarized because of the hydrogen bubbles. So if these bubbles gets bursted at the site of this electrode, then it is actually the detrimental factor, and in ECM process it deteriorates the surface quality. So this particular phenomena has been utilized for machining of electrically non-conducting materials and is known as electrochemical machining. So if we try to see this shell, this is an experimental setup for glass micro machining. So here it is an electrochemical shell. It's a general very schematic diagram, and there's a counter electrode which is actually anode. Now if this anode is largely a bigger in cross section as compared to the cathode, then you'll find that the cathode is being surrounded by H plus ions and then hydrogen is liberated. Now, if you bring this, if you increase the DC voltage, because as you may be knowing that in electrochemical machining, the current is kept quite high, maybe 250 amperes or so, and the voltage is kept below 20 volts. So if you increase the voltage beyond 20 volts, maybe 30 volts, 40 volts, 45 volts, you will find that there's a sparking in this zone. So once there's a sparking in this zone, there's a sparking in this zone, and if you bring this thing in the vicinity of this thing, then you will realize that the workpiece, like suppose this is a glass material, which is a electrically bad conducting material, that will get machined. So this is a schematic diagram, and this phenomena is known as electrochemical spark machining. Now, so this is phenomena is also known as electrochemical discharge or electrochemical spark machining. So, like this is a setup which was developed in 2007. This paper has been published, and here you can see that what they have done, they have taken this EDM machine, which is a numerically controlled EDM machine, and here instead of having dielectric, they have filled it with the electrolyte. And this is the glass workpiece, and this is a rotating electrode on the top, and once it is being increased with the voltage below above say 50 volt, they have realized that there's a machining here in this glass workpiece, and this is a gravity-fed, counterweight gravity-fed mechanism, and the depth which is being machined is being monitored or being measured by this digital indicator. So this is the paper which is published, and the micro tool which has been made, that is by the wire electric discharge grinding process. So as you know, in order to maintain the accuracy, the micro tool is not separately developed, rather it is fabricated on the machine head itself, because the setup errors will not be much in that case, or rather they won't happen. So this micro tool is being machined by wire electric discharge grinding process on the machine itself. So just try to have a look on the two kinds of electrodes which have been developed. One is having a diameter, circular cross section, having a diameter of around 200 micrometer, and another is that you are removing the material from the two sides, so you get a section like this, correct? And this dimension is, one side is definitely 200 micrometer, but the other side is a variable side. So they have tried to study the effect of this. So with this kind of tool, this Pyrex glass has been machined, and you can see the working depth gets saturated, and this is how the shape of the tool, the hole is there in the Pyrex glass, and this is the outer diameter, which is quite large. It is around 570 micrometers as compared to this. The tool is only 200 micrometer in diameter. So this overcut which you have is being actually controlled by changing the shape of the tool. So once the shape of the tool has been reduced or rather changed by doing the sidewise cutting this way, so the overcut has been brought down, and that's how the machining has been take place. So from this graph, what we can see that if we are changing the sidewall thickness, if it is made smaller, you are finding that entrance diameter is smaller. However, the machining time is larger. So that's obvious, because most of the time when this is thinner and thinner, the sparking which is happening on the side walls that is not likely to reached or available for the machining, and that's why this kind of observation has been there. So you can see for very optimized condition, almost vertical hole has been machined by that kind of a tool, and here they have a 40 volt rectangular pulse with a 2 millisecond to 1 millisecond as a T on to T off time. So similar kind of behavior. Now I would like to go back. Now these experiments were done in 2007, you can see. But when I was a MTech student at IIT Kanpur, we have developed another setup, though I was not directly involved in this work. Now here, what we did, instead of having a gravity upward feeding mechanism, we had a servo-controlled feeding mechanism by which we are taking this work table upward when the machining is taking place. And instead of having a hollow tool, we had a tool from where the stream of the electrochemical or electrolyte is being supplied from this chamber, and there's a tool kinematics that this tool also rotates. So the similar experiments, but in a different setup, they have been done much earlier. This paper was actually published in 1998, but this work was done in between 93 to 95. And you can see that with the different tool kinematics, we could do a lot many holes in glasses or ceramics or some sort of quartz kind of glasses using this particular technology. And here the tool eccentricity has also played an important role, that there's an optimum tool eccentricity through which we got the maximum machining depth. Similarly, you can see here that the machining rate goes down with the increasing depth. That happens because you are having the less availability of the fresh electrolyte for the machining. So this particular process is somewhat a micro machining process which has ability to do the micro machining on various materials which are electrically non-conducting. Now, my job used to be that we used to study the process phenomena. Now, it was at that time, why this sparking is taking place, that was not known. Now, you can see that in 2004, this is the paper published, which says that when you increase the voltage, this U here is voltage and this is the current. So if you increase the voltage in this shell, the situation is like this, that in the very beginning, this is the larger electrode, and this needle kind of thing which you're observing is the cathode, so there's a very large difference in the cross-sectional area of the two. So in the beginning, you have reaction like this. When you increase the voltage, the reaction increases, and there's a complete blanketing of the tool by the hydrogen bubbles, which you can observe here. So these are the photography by the high-speed camera. Now, once you keep on increasing the voltage beyond the critical value, you will see that there's a sparking in the vicinity all around this tool. And if you bring your workpiece material, which is electrically bad conducting, then you will realize that the machining takes place. So this is the kind of idealization which has been done by one of the authors, and what they suggest, that this is the kind of blanketing because of so if this is the tool and this is the hydrogen blanketing, and once there's a discharge through this hydrogen, that is because of the dielectric breakdown, then you realize that there's a crater formation and machining takes place, which is called electrochemical discharge phenomena. That is another author from IIT Kanpur itself. They have shown these optical photographs that once there's a sparking, this is how the crater formation is taking place in case of the glasses, and you can see there's a very multiple craters here, and here also they have shown. So this shows this is an evidence of melting and vaporization through these micrographs. Now the idea at that time, now this photography was also done in 2002, you can see, correct? So when I started working around 93, 94, then there was no theory which was proposed for electrochemical discharge phenomena. And the theory which was there, that was named as switching. This was named as switching theory, and it was proposed by Basak and Professor Amitabh Ghosh of IIT Kanpur. And here what they said, that if this is the surface of the electrode which is fully blanketed by the hydrogen bubbles, then on the sides of where the bubbles join each other, which is known as the bubble bridges, at these locations, because of the resistance being very high, this phenomena which is similar to opening of the switches, and you get these kinds of sparks, which is termed as switching theory. However, this idealization was not very convincing, and it was not definitely convincing to me and to my supervisor. So we developed our own concept, and what we said, so there were many limitations of this switching theory. So this switching, now one of the typical limitations which we observed, that the switching phenomena is something which is not based on, because these bubbles are electrochemical material and they cannot burst like that. So this was not very convincing. The basis of switching theory was Paschen's curve. This was the curve which is only valid for the Townsend discharges. So if you study the theory of discharges through gases, like there's an experiment that if there's a test tube, you have electrodes, and you keep on reducing the pressure inside the test tube and keep on increasing the voltage, you will find different kinds of discharges which happens. So here you can have a look that these are the discharges which are called Townsend discharges. So these Townsend discharges are actually produced when the pressure is very low, only few millimeters of mercury. So, however, the pressure, if you try to see in this electrochemical shell, correct? So if you see the pressure, it is almost atmospheric pressure, because the surface of the electrolyte is exposed to the atmosphere. So this particular theory did not work. It was not very convincing. There were other drawbacks also, like the order of the current. It was too high as compared to what is there in case of Townsend discharges. So we did not, very happy with this particular theory. So there's another theory which was proposed. So what did we propose? That is called as a wall theory. It was proposed in the paper which was published by me. So we called that these are the arc discharges, because these discharges happen only when the pressure is approximately of the same order as atmospheric pressure is. And we could also match with the frequency of sparking with the experimental one, and there's no overlap between the two successive sparks. So the discharge time is, we could consider as 50 microseconds, and the inductive effect is assumed to have insignificant in this process, though it may definitely be there. So based on different analysis, like the analogy has been seen between the theory, that is the theory of discharges through the tubes, and what is exactly happening in case of the discharges which are taking place for electrochemical spark machining. So here what we could realize is that an equation of this kind, which is actually being proposed for arc discharge, that holds good. So what we tried to plot, like these are the VI characteristics for the material combinations when we taken these two constants A and B, from a very old book, which is typically on the discharges through gases, we could realize that we are able to match this behavior. And frankly speaking, these are the experimental curves which were done by Basek in 1992, and this is the zone where the discharging takes place. So we have realized that there's a perfect match. The conditions are matching well, so the proposal has been that this is nothing but the arc discharges. And this is the kind of circuit. Now try to see. This is the circuit which we have proposed. In the very beginning, when there's no sparking, this is the kind of circuit of the electrochemical shell. This is the internal resistance of the battery or cell, and this is because of the some sort of resistance which is created because of the blanketing which is taking place, and then there's a bubble formation at critical accumulation condition, and this is RB is the bubble resistance, which is actually tending to infinity because there's a gas and there's nothing, so it has to break down. So once it breaks down, that is at the time of sparking, and the the bubbles which are in the vicinity, they also gets bursted. Now please realize that this particular hypothesis was developed around 94 or so, which has been proven later in 2004 by this particular experiment, that is the high camera photography of the electrochemical shell phenomena. So what I would now like to go ahead is, so with this all, we could see the voltage across the bubble, we could calculate because it is the 10 to the power 6 volt per meter is the order of the electric field, and from here we could realize the bubble diameter. So with all this data, we could create a finite element model of this particular process, correct? So please try to see that how complex the model we have developed. The model is like this. This is a 3-dimensional domain. Is it okay? This is a 3-dimensional domain, having all the sides insulated, because this particular size is large enough that no heat is passing through these boundaries. That is, del T or del N is 0. And on the top surface, this circle which you are observing, this is nothing but the projection of the tool. So the spark, which is hypothesized as a square in cross section, just to facilitate the finite element formulation, moves randomly below on the surface of this workpiece, and its location may be sometime here, sometime here, sometime here, sometime here, depending upon the T discharge. And what we have assumed that at a particular instance only one spark takes place. And on this surface we have taken as Q is heat transfer, flux is HT minus T infinity, that is the convective heat transfer. So we did the complete formulation of this problem using Galerkin's approximation, and this is the differential equation which we solved, and this is the boundary condition that this domain is sufficient enough that no heat crosses through these boundaries. And then because this phenomena is a time dependent phenomena, because there's a spark and the heat is absorbed in the workpiece material and it travels, so it is a transient phenomena, and this Q is Q star is only applied on S star area for a time less than or equal to T discharge, and after that its location will change, and this becomes 0 when T is greater than T discharge. So it's a very typical formulation, and here this is the convective heat transfer equation which has been seen, and this is in the beginning the temperature of the entire workpiece has been considered to be T uniform, which is equal to the room temperature of this thing. So we did the complete finite element formulation using Galerkin's method, and after that it was typical to do the mesh generation. Now it was the time in 93-4, there was no powerful finite element package was available. Now today if you want to solve this problem, you can do the mesh generation and develop the connectivity matrix in a software like Ansys, take it out, use in your Fortran code or maybe in your MATLAB code. However, at that time even this facility was not there, so we have to develop our own, mesh generation code and also the connectivity matrix generation code, which we did, and also this surface, because there has been surface elements in order to analyze the problem in terms of convective heat transfer and also the absorption of heat at a star. So this particular surface matrix was also developed. So this is node numbering scheme and surface elements that has been shown here. Then another important part of this formulation was random location of spark. So this spark is at one place, as I was telling you. If you see this particular diagram, at this moment the spark is here, the next moment spark may be anywhere else, maybe here. Third moment it may be here, fourth moment it may be here, fifth moment it may be here. So it is randomly moving. So this is to be modeled. So this particular phenomena has been modeled by having some sort of random number generator. So we used to have, at that time in our Unix platform, we used to have NAG routines. So using those NAG routines, we calculated, or rather we generated the random numbers which was connected to this code, and that used to decide that what would be the location of this spark. So with this, we tried to calculate the temperature contours. So temperature contours were controlled, and also we have taken care that the element where the temperature goes beyond the melting temperature, that mesh is being modified, because by changing the value of heat capacity, we could actually remove it virtually from the mesh. So that kind of formulation was done, and then the volume of the material that is being removed is being calculated by this formula. That is the formula of volume of hemi-ellipsoid, that is given by 2 by 3 pi ABC, where A, B and C are the half axis of the ellipsoid. So these were the contours. Now you can see that this is a very typical example of virtual manufacturing, you can say. Today, if I would have had the facilities of computing and also rendering the temperature variation or the situations in the present circumstances, I would have shown them in a three-dimensional manner, but it was very difficult. Even the windows were not there. So we used to write the things on MS-DOS. So this software was a surfer software which used to make for us the contours. So here, this is the melting temperature contour depth-wise, and this is on the top surface. So we can understand the size, the overcut, as well as the depth of the machining. So we did different computations. Now, few more considerations we did, that the thermal conductivity of these glasses, the workpiece material, which used to be the soda lime glass or borosilicate glass, that is dependent on the temperature. So this makes the problem non-linear also. So the finite element problem which was solved was non-linear and transient, with the heat source randomly moving on the surface of the workpiece. So you can now have a feel of the complexity of the problem, and this is how we calculated the overcut of this is the tool, and this is the maximum size, because this is the machine profile. So this is the maximum size. So the difference of the two, RT, RO minus RT, is called the overcut. and this is the result for different supply voltage. We could see the overcut that increases, obviously it has to, and the minimum penetration depth that is supposed to become some sort of saturated. That kind of trend is being observed in case of the depth characteristics. And the material removal rate has been also computed with an overall efficiency of 0.5%. This is the ejection efficiency. This data we have considered from one of the table. So you can see that these are the experimental findings and these are the findings of our model. So this particular model, finite element model, has been utilized by one of the companies from Switzerland to optimize their process. Now here the limiting or the limited depth penetration phenomena which is being observed in case of electrochemical spark machining, that was also explained by the intermediate contours. So you can have a look on these intermediate contours which have been plotted after 10 sparks at a supply voltage of 40 volts. And here you can realize that these are the unmelted islands which remain, and they actually hamper the further machining, and that's why the machining ceases and you won't be able to process the things further. And the probability of sparking being higher in the region of higher current density leads to the upward shifting of the discharge zone. So that's how we could explain the limited penetration depth characteristic of this process. So this particular finite element work that was done long back is one of the, I'll say this particular paper has been cited a lot because of the two reasons. One is the theoretical development of the process phenomena, and second is the contribution in terms of finite element modeling of the process. So this is one particular case, I'll say, in terms of mechanical engineering or manufacturing science application of finite element analysis, which we did. Now let me show you, because many of you know that I work in the area of additive manufacturing also. So I'll show you one more example of similar kind. Okay, so this is too slow? I don't know. So as you all know that I work in the area of additive manufacturing also. So let me show you one more example. Why this is too slow? I don't know. Morning I downloaded these things, but it's not going beyond this. क्या इशू है इसमें? हाँ दो. If you have hotspot, give me the hotspot. ये है. It's working fast. Yeah. Yes. Okay, so let me start. Now, you may be aware about this particular process, which is called selective laser sintering process. Correct? So in this particular process, there's a powder bed, and the thickness of this powder, which is polyamide, it is as small as maybe 250 microns or so. And the the laser comes from the top and it increases wherever the laser spot goes, you will find that at that location you are able to actually sinter the material. So the process is that there's a recoater which spreads the material, and after that this powder bed is exposed by this laser beam. So wherever this laser beam goes, this brown color thing, the laser has gone there and it has solidified this material. The platform goes down and again there's a next layer that is being coated. So this particular process is called selective laser sintering process. So we have made an attempt to model this phenomena. Okay, so yeah. So we have tried to do the modeling of this process, simulation of voxel sintering in SLS process. So this is the work domain. It is actually similar kind of formulation, but it is a moving heat source model. So this is the heat source which moves from here to here, and this is actually the laser source. So we did the formulation, and the formulation is actually based on the porosity and the consolidation of the voids of nitrogen which are present in between the powder particles. So with that, we did this formulation. This is the differential equation which we have seen, and we tried to consider the latent heat also, latent heat of melting also, the density variation with the time also, and finally this is the finite element equation, which is a time dependent equation which is solved by using Crank-Nicolson method. So with this kind of work domain, we have tried to solve this problem. Now the entire code has been written in MATLAB. This work was done in 2010. One of my MTech student has done this. So this is how the laser beam is moving. So you can see when a work was done in 95, we could not display like this. So even today, if you do it, you have a better way of presenting your results. So this is how the laser beam moves, and this is the temperature profile. So different ways of representing the same, and this is the voxel. Like this is the voxel which is getting solidified. So this is the result which you have derived in case of we did in MATLAB. Now in order to validate our finite element model, this is the single laser hatch experiment which has been done very first time in our lab, correct? So what is being done, we modified in such a way that the laser moves only once like this. So once the laser moves like this, a strip kind of thing is being produced. You can see this is the strip. And these are the powder particles. So we did the SEM from the side. So you can see these are the voxels which are being formed. They are visible here. Here also they are visible. So we measured the depth as well as the thickness of these voxels, which has been, we tried to validate them based on the thickness which we have got here. This is the simulated thickness and the depth of the voxel, and this is how the results match. So this is the kind of work which we did for additive manufacturing. So the power of finite element method is something which you can realize from these two studies which are based on the manufacturing sciences, and the limitations also you can understand, because once we try to model an actual phenomena based on the statistics we are able to actually talk stochastically. We are able to give a band that this is the situation, and under these circumstances, the results are likely to vary from here to here, and this is the probability, correct? But these models are very deterministic in nature, and this is how you can validate these models, correct? But in these circumstances, when there's a no solution method available, it is one of the best ways of doing the things. So with this, I'll conclude here, and if you have any question, I'll be happy to answer. Yeah. Any question? So you try to do hands-on, and this Tushar is available here? He is there. So today, can you do such things with Ansys? Can you model the first one? Second one you can do. Yeah. So second one, that is a laser moving heat source model that has been coded now, but still having the randomness of heat source, and that is probably very difficult, and you have to go for their APDL programming or some sort of what you call as, what are those routines called in Abacus? You can have a separate subroutine, and you can connect it with the there's an interface, you can connect it with Ansys and try to do the computation based on that. So that's how you can probably do, but still the program doesn't, like one very classical example which I would like to tell you, that nowadays you might have heard that people are trying to simulate ballistic simulation, that is, bullet is being fired on a panel of composite or something like that, and they're trying to simulate the phenomena using some Abacus or maybe some other package, like there's some other package also. But I can tell you that all those simulations are much, much away from the actual situation, because the reason is there's no science which has still been established. You even don't know what is the differential equation which can actually model or represent that abstraction. Once you don't know that, what you're solving, only God knows. So if you use the software as a black box, you will do something, it will show you something, some color will come, you can publish, and you will become very happy. But it is nowhere near the reality, because if the bullet is being fired, you can imagine the kind of strains it is likely to have and how the material is going to behave on those strains. Even those material models are not available. So neither the physics of deformation is known, nor the material behavior is known, and I don't know how the people are keep on doing the things using these softwares. Am I correct? So you have to be very cautious when you are using and doing such things. So the things start with the differential equation. First you have to use the differential equation and then proceed. Even today you will find that complete solution of Navier-Stokes equation has not been done. You put number of assumptions, you take number of hypotheses, and then only you reduce those complex set of equations to a simpler equations, and you are able to solve those things. But my statements may not be that updated because I'm not a person in fluid mechanics, but still I feel that that's the reality which used to be a reality till 2010, correct? So with these words, I stop here, and if you have any question, I'll welcome you to ask. Thank you. make a move now because I have a train also. Thank you very much.
Next session will be started within 5 minutes. After tea break. So you all can come to have. journals in the field of CFD. So I welcome sir to deliver a lecture.
I thank organizing committee for giving me this opportunity, for calling me here, for giving a presentation. Without knowing whether it is a fill gap arrangement or some misunderstanding of organizers, that I am capable of delivering this lecture. Okay, as he told that my background is CFD. Yes, my background is CFD. But in very first company where I worked after PhD, I was developing CFD software based on FEM. And you know, to know finite element method or to implement finite element method, you have to first learn structural analysis. Structure you have to learn, because finite element method has evolved from structural analysis. Therefore, I could know from very small things to implementation of the software. I implemented axisymmetric element. Those days in 93, 94, there were no axisymmetric elements in any software. And then I implemented iterative solvers, conjugate gradient and biconjugated gradient method. And those elements were basically in market that time. Now that software is not very popular, so taken over by some other company. Okay, to start with finite element method, let us understand that where it is applicable. We have heard the terminology continuum mechanics or continuum. My teachers used to talk about continuum theory or continuum, but I could never understand what is continuum. So let me explain you in very simple words. The continuum is, you can say that the smallest lump of the material where you can assume that the variation of material properties or material property is uniform, and the variations in other quantities, for example, displacement, temperature, velocities, etc., are uniform, rather continuous, not uniform, but continuous. And there is no discontinuity. So here, the assumption is that material is not discontinuous, it is continuous, and that is basically continuum, that is called continuum. So professors generally show you these diagrams, and where 9 stresses, 9 components of stresses, how many components? I think there are more than 9 components. 9 components of stresses. If basically there are normal stresses and shear stresses. These stresses are used to formulate the structural problem. I will not go in much details because FEM as such is very difficult and voluminous theory. But let us understand in very simple word what is it? What is the FEM? This is a numerical method where you break the domain in smaller parts and satisfy the equilibrium equations on those parts. And in this way, you find several equations, and those equations are interconnected. And those interconnected equations you assemble and you can solve using any algebraic method. That could be Gauss elimination, or that can be a conjugate gradient method or biconjugate method, etc. So the element comprises of nodes, and there can be various type of geometries, triangular, depending on the problem. So let us look at the application of FEM, already talked by previous speaker. Let us look at the, from formulation point of view, not from analysis point of view. Let us look at this flow chart. Define the governing equation. You have to first know which governing equation basically explains the physics of the problem you are going to deal with. And then you have to know boundary condition. Obviously, boundary condition and initial condition have to be known, otherwise you cannot solve any problem. Then you are dividing the domain into elements. Define a special variation in the pertinent variables. Dividing the domain into elements or dividing the domain into a number of parts. Other methods also do the same thing, like finite difference method. But there is no interpolating function used here. But here you define a special variation in the pertinent variable, derive a discrete form of the governing equation. The differential equation is eventually reduced to algebraic equations. From the relevant matrices, you form the matrices, and from the relevant matrices, update element matrices. It's relevant matrices, solve the required variables, check for convergence, because you need to have converged solution. If it is a linear problem, then solution is converged in first step itself. If it is non-linear problem, then it takes several steps. Now the question many students would like to ask, what is a non-linear and what is not linear? If coefficients of the variable in the equations, because equation you will have a coefficient and then you will have variable. If coefficients of the equations are independent on the variable which you are going to compute, then it is a linear problem. But if those coefficients are coefficients depend on the variable you are going to compute, then it is nonlinear problem. There can be other kind of nonlinearity also, but we will not discuss it here. Displacement method. In structure, three-dimensional structural analysis, displacement method is used. In the past, several other type of methods were being used. And if long before, maybe 20, 30 years ago, you will find that software used to have beam element, so on and so forth, depending on the theory it's being applied. If it is beam element, then you will have 6 degrees of freedom. Displacement method, for a three-dimensional problem, you have 3 degrees of freedoms. Displacement in X, Y, and Z directions. Rest of the quantities in structure, those quantities are stress, which are basically of interest to us. Those quantities are derived from or computed from the help of displacement we have obtained. So to understand how FEM works from formulation point of view, to understand the step itself, let us take a very simple problem. And I think nowadays we are more tilted towards AI, computer language, etc., etc. So probably these things are not being taught by teachers nowadays. But let me explain this. This is a very simple problem. It is a structure that comprises of 3 parts, and you can say the beams, and these three beams have different area of cross section and a different length. But let us simplify further that it has got stiffness. Any structure has got stiffness. And what we are doing here, in this method, we are interested in finding out the displacement at the joints. Okay. So in left the image tells about just it approximate, it shows as if it is a spring, and we know that spring has got stiffness. So that's a representation. And then middle one, in middle one, what we are doing, we are applying forces at each joints. So top, we are applying force P1, and the second junction, we are applying force P2, P3, P4, so on and so forth. I think it's very simple. Now, because of these forces, we have got displacement. If you are applying force on certain thing, then there is going to be movement or displacement. However small is the displacement, there is going to be displacement. For example, if you push the wall, there is not going to be visible displacement, but there is necessarily going to be displacement. So there are displacements, and these displacements are delta 1, delta 2, delta 3, delta 4. I am not a regular speaker, that's why my voice is not very good. So what we do now, we take small segment around each joint, and let us apply the equilibrium condition. What is equilibrium condition? Here is the force balance. And force equal K into delta X or delta. So first segment, rightmost image, you can see here, the first segment has got displacement, resultant displacement or effective displacement is delta 1 minus delta 2. I think it's very easy to understand because joint 2 has moved by delta 2 and joint 1 has moved by delta 1. So net displacement is delta 1 minus delta 2. Okay. Similarly, other nodes, other points or nodes, joints, we can find the displacement. And now what we are doing, we are using the equilibrium condition, and we find these equations. It is very simple. Now these equations can further be rearranged. You can see here. And if you express this in terms of matrix, then you will find there is a recurring pattern. Okay, and there are several methods, matrix inversion methods available to solve these equations. So you have got a matrix, square matrix, and then you have got variables delta 1, delta 2, delta 3, delta 4, and loads P1 to P4. Exactly this is how finite element method works. The difference is that here we have concentrated on joints, and we have no idea what is happening between the joints, what is happening to the member between the joints. In finite element method, we concentrate on joints. We are interested in finding the values at joints. but we want to find out the values in between also. So to find the values in between, we have to use certain kind of interpolating function. And that's where the term comes shape function. Let us go a little further. I have got only 16, 17 pages. If it is over, please don't feel bad, because maybe it doesn't pull on for more than 40 to 50 minutes. Look, let us first look at this one, that here in the equation, maybe if it is constrained, if it is indeterminate structure, then there is no constraint, only loads are there. If it is determinate structure, then one of the point is going to be constrained. If it is constrained, for example, if you know delta 1, then you don't need to keep delta 1 in the equation. You just delete the rows and columns, first row and first column, and then your matrix becomes 3 by 3, and you solve 3 variables. If you do not have force on all the joints, only you have force P1, then rest of the force you equate to 0, and hence you solve the equation. Okay, so I will explain the shape function, but before that we'll go to this topic, that is weighted residual and variational approaches. There are two kind of approaches in FEM. One is weighted residual and other one is variational approach. A variational approach is used for the problems where you can get a scalar quantity that actually describes the equilibrium or stability of the problem. For example, in structure, potential energy is a scalar that is called functional. If potential energy of any structure is the smallest, then it is the most stable structure. Weighted residual method is used for those problems where there is no such functionals are available. So weighted residual method is used for fluid mechanics problems. Here there are two differential equations. It's just notation, and that is the biggest problem of FEA, that it is very difficult to make out what is going on here. In the books, basically, notations are very peculiar. AU, BU, U is basically displacement. A is differential operator, that could be anything. Maybe it's a very long differential operator. So we find the functional, this is basically we are talking about a weighted residual method. So in weighted residual method, what we do, we assume that we are already knowing the solution. We know some approximate solution, but this approximate solution will not satisfy the governing equation. So what we do, we find that how much deviation is there from the governing equation. So we multiply with one weighting function, W, and integrate these equations on the domain and then equate it to 0. So our goal is that this weighted residuals of the equation have to be 0. Now, there are different methods depending on what weighting function you are using. There are several methods. I remember only 3 at this moment. Point collocation method, root mean square method, and Galerkin's residual method, Galerkin's method. In Galerkin method, the weighted function is same as shape function. अब shape function क्या है वो हम बाद में आपको बताते हैं, अभी shape function हमने आपको बताया नहीं. And the variational method, we will look at this general equation. This equation is given in Cook's book. This is potential energy. Pi, जैसे pi लिखा हुआ, that is potential energy. That comprises of strain energy, first term, and second one is pre-existing energy, that is already if structure is stressed, then there is going to be certain amount of energy. Then you have energy, potential energy due to stresses, stress and due to strain, and you have potential energy due to body forces. I think we students, do you know what is body force? Teachers को तो सबको पता है. Body forces are those forces which are scalar. So not necessarily scalar, but weight is one of the body force. And then you have a surface force. Phi represents here surface force. You will have potential energy because of surface force. And then there is going to be potential energy because of the load you are applying on the structure. If you apply load on the structure, then there is going to be potential energy in the structure. Now this potential energy you are going to minimize. Let us not go into details of these equations because it's basically difficult to understand so soon. So here we are going to minimize the potential energy. So what do we do if you want to find maxima or minima of any function? We just differentiate and equate to 0. Many times assuming that it is going to be minimum, but to establish whether it is minimum or maximum, you have to do second differential also. Second time also you have to differentiate. But here, fortunately, first differential itself gives you the minimum of the potential energy. With this minimum of the potential energy equation, you find an algebraic, you can derive, it's not that simple, long process, but you can get an equation which is KD equal R. K is stiffness matrix, that is called stiffness matrix. In case of one-dimensional problem, we have seen that stiffness is very simple quantity, but in case of FEA, stiffness comprises of several things. There is going to be material matrix, and many researchers here, they know that it can be isotropic material, anisotropic material, and depending on that, the complication of this stiffness matrix increases. Then you have D. D is unknown displacement, which you are interested in finding out, and R is the load conditions. Now we come to shape function. So the example we have seen previously, that one-dimensional structure. So if you are dealing with one-dimensional structure and you want to do finite element analysis, or you want to develop finite element equations, then you have to use interpolating functions. Between two joints, in order to know what is the value between two joints, you need to have an interpolating function. This interpolating function for a linear, this is a linear interpolating function. A linear interpolating function is such that its value at node, if there are two shape functions you have to define. One at node 1 and other at node 2. I think bit difficult to grasp at this moment, but this is a shape function. This shape function is not a single shape function, but there are two shape functions. One is satisfying node 1, other one is satisfying node 2. How you find shape function? Shape function 1 has value 1 at node 1 and value 0 at node 2. And shape function at node 2 has value 1 and 0 at node 1. If you take 4-noded element, that was one-dimensional element, this is two-dimensional linear element. If you take two-dimensional linear element, then you will find 4 shape functions. One shape function related with each node. And the property of this shape function is that its value at that node where the same shape function is defined is going to be 1, and the rest of the nodes its value is 0. तो ये फाइनाइट एलिमेंट मेथड ये चीज़ है. फाइनाइट एलिमेंट एनालिसिस तो बहुत आसान है, बट मेथड ये है. एंड फॉर 3-dimensional elements, the shape function is given here, and depending on I value of node, and you can derive you get the shape function. Not going into much details, otherwise it's going to be very boring. Now, look, this is very important to understand, and I think very few people will tell you, because I am a lack of good words, that's why I tell you all these things. What we have seen so far, that we have defined a linear element, and that is straight, or a quadratic element that is perfect square. Do you think in practice we have perfect square structure? ऐसा होता है कि आप परफेक्ट स्क्वायर मिलेगा? नहीं होगा. या प्लेनर आपको स्ट्रक्चर मिले हमेशा? It's not possible. I mean, in practice, you may have zigzag as curved structure also. But the element, you are assuming it as a square element. Why you are doing that? I could have constructed several type of elements and then solve the problem. Why we are doing that? Because if we take square element and if we satisfy the equilibrium equation for one element, then we can get similar equation for other elements as well. And therefore, whole exercise we are doing for one element. And rest of the elements, the equations we are assembling because there are interconnecting nodes, and hence we get several algebraic equations which are interconnected and solve it. Now, isoparametric transformation, what it does? The shape function we have defined, it has its own coordinate. And what was the coordinate? It is local coordinate, and it is between -1 and 1. Now, practically, if you deal with the structure, then it is going to be in xy coordinate, and structure is not, you cannot express this as a square segments. So eventually, you have to transform those square elements into the elements or the segments which you have constructed in xy coordinate. जो मेश आपने बनाया है एनसिस यूज करके, उसके एलिमेंट्स और ये जो स्क्वायर एलिमेंट्स हैं दोनों डिफरेंट हैं. बट द फार्मुलेशन यू हैव डन इज you have done the formulation on square elements. Then there has to be some way of mapping those elements together. And that is called isoparametric transformation. In this transformation, there are two equations, 1 and 2. U is the nodal variable, that is displacement, or it's not nodal displacement basically, it's a displacement in the element. And n is the shape function, and D matrix is the nodal displacement. So if you know the nodal displacement, and you know the shape function, then you can find displacement anywhere in the element. Now, similarly, you express x coordinate in terms of shape function and local coordinate. So x is global coordinate, that is x, y, z coordinate. N is shape function, and t is local coordinate. Isoparametric word comes from the fact that you are using the same shape function for formulation of the governing equation and for transformation of natural coordinate to global coordinate. And this is called isoparametric transformation. But this transformation is not going to be very ideal, because we'll see later how this transformation, what it does actually. If it's becoming too boring, then you please tell, and I will skip quickly. This is a rectangular element in natural coordinate, and this is element, the same element is mapped or is transformed to global coordinate. तो वहाँ पर तो आपने देखा perfectly square, and here it is not square. So that is why you need to have transformation. And in actual practice, you will encounter these type of elements, distorted elements only you will find. You will never find perfect square. But perfect square is used in background. And let us understand why isoparametric element, why you use isoparametric element at all. The model has irregular boundaries. सीधी सीधी ऐसे flat boundary नहीं हो सकती है. This is going to be wavy boundary. Then how will you represent that? If you represent with square element, then you have to have very, very fine elements. And therefore, the number of elements you are going to use are going to be very, very large, and maybe it's computationally it is not economical. The beauty of finite element method is that because of this transformation, you use less number of elements and solve a complicated problem also. The geometry is not perfectly rectangular or cube. We know the geometry cannot be always rectangular. Isoparametric transformation generates non-rectangular elements. Therefore, mesh grading and modeling of irregular boundary with comparatively small number of elements is possible. Mesh grading का मतलब आपने कहीं पर एक साइड का लेंथ बढ़ा दिया, कहीं पर कम कर दिया, डिपेंडिंग ऑन, या आपने certain region you have used finer elements and then certain region you have used coarse elements. Okay, if you do transformation, then it is going to give you, if you transform, then obviously there is going to be ideal thing you are transforming to some real thing, then there is going to be some effect. Some penalty is going to be there. So that penalty is Jacobian. And this is the matrix, and you can see here this matrix relates global and local coordinates. This is Jacobian matrix, and it is in two dimension. This Jacobian, this is determinant. This is a matrix, but you find determinant actually. So the value of J is the degree of distortion in the ideal element. Okay, so the people who use software, they will tell that देखो Jacobian 0.3 से कम नहीं होना चाहिए. So if Jacobian is low, it means distortion in the element or distortion from ideal to real element is very, very high, which will definitely introduce a large error. Okay, we'll now talk about mesh quality parameters, because let us not talk much mathematics. थोड़ी सी practical चीज़ें बात करते हैं, because you will have 2 weeks and there will be very learned people who will talk about so many kilometers long equations. I don't want to go into that. The mesh quality. Why mesh quality? Because you have learned that the ideal element, which was rectangular or cube, has been distorted while we did meshing. So we have to actually find out how good is my mesh with respect to the ideal mesh. So therefore, there are certain quality parameters which have to be looked into and which have to be actually checked before you solve the equation. Let us look at those quality parameters. First thing is aspect ratio. Aspect ratio, we all know that ratio between the length of the two sides of a rectangle, aspect ratio. In case of ideal element, the aspect ratio was 1, because it was square, so it's 1. But in real practice, you will encounter the elements which do not have aspect ratio 1. So you have to check how much is the maximum aspect ratio in our mesh. And by practice, people have actually defined certain limit. So you can see here in the table, I think it's visible. And then taper. So visually define what is taper. One side is longer than other side, and hence there is distortion from square. Warping, this is very dangerous quality parameter. This has to be actually controlled, otherwise solution is going to be wrong. In case the square or the ideal element we have defined is a planar element. It is in 2 dimensions, x and y. But if you are dealing with the curved boundary or curved surface, then this surface will be represented by x, y, z coordinate. Hence, practically, if you are meshing it, then you will get an element which will have all 3 coordinates. And if all 4 nodes are not in the same plane, and one node is out of the plane, then it is called warpage. So please, if you do not understand or you are not able to make out what I am telling, then please intervene. And then warpage angle, skew angle. You can see here the rectangle has become triangle. possible. There are 4 nodes, but it's skewed in such a manner that it becomes triangle. So this skewness has to be controlled. Jacobian is very important parameter, and its ideal value is 1, but it is good Jacobian value is 0.7 and above, but many times if geometry is very complex, you can go up to 0.3 also, but not all the elements. We have to make it sure that all the elements are the number of elements failing in the mesh should be the minimum. It should not happen that all the elements in your mesh are failing. Then you will have very, very wrong result. Then internal angle. So you typically after meshing, if your geometry has got several segments, then you don't mesh all segments together. Nowadays people do not want to spend time, so they will just mesh whole thing with triangular elements at one go and everything is satisfied. Otherwise, if you are doing good meshing, then you have to check mesh continuity, because if there are 2 segments, then there is going to be nodes from both the segments on the boundary, and hence there are going to be duplicate nodes. So you have to check free edges. There should not be free edge in the structure. Coincident nodes. There should not be 2 nodes at one point. Duplicate elements. You should not have duplicate elements. And these all options are available in softwares. Element normal or 2D mesh. Many times element normal is very much related with warpage. Coincident loads, even load conditions cannot be coincident. Aspect ratio, warpage, Jacobian, skew. So if anybody interested here, then he can formulate using weighted residual method, a one-dimensional heat conduction problem. Just I am giving you a glimpse of that, and with this presentation, you will not fear what is the theory of finite element method. You will be able to do formulation. And for a simple problem, eventually you get element matrix AK by L, and this is 1, -1, -1, 1, T1, T2. Just linear element, 2 nodes. This is equation you have got, and then AQ1 and AQ2. Q1 and Q2 are the flux condition, heat flux conditions. That is similar to stress condition or traction condition. And if you can construct equation for n number of elements in the geometry and assemble them and solve it. So that's all the mathematical part of that. The question is here that why should we not take FEA results for granted? Look, if we are in academics, we saying that Aham Brahmasmi is applicable to all, to us, because we are creator, we are fabricator, and we are disposer. We define our own problem, we solve it, and we interpret it without any accountability what's going to happen to the result. So therefore, we can do anything we want. But in industry, it is not done like that, because industry, the analysis is done based on the demand. If you do analysis and it fails, then you are penalized. And the result is very quick. It's not somebody read your paper after 2 years and then he found some mistake. It's not going to happen. Here In 2 days' time, you will get feedback. So let us not take the FEA results in a manner that it is everything. So why we cannot take it for granted? Because the governing equations, because of the governing equation, first the governing equation itself. The governing equations are representing a certain phenomena based on certain assumptions, and that may not be perfectly applicable. Then the physics of the problem, large deflection, buckling, nonlinearity, dynamics, linearity and nonlinearity, all those things come into picture. Why? Because if you are doing structural analysis and linear structural analysis, it may happen there is a large deflection which you haven't accounted for. And if there is a large deflection, then it will give you altogether different result. Because successively, this deflection is going to, or rather I would say that this large deflection will result in non-linearity, and hence the results are going to be altogether different. So the physics of the problem you have to understand. I will give you, show you one example. I will basically narrate one example where because of local buckling, the component has failed. Then the numerical approximation, discretization, transformation, integration, etc. Integration is also done here. And then transformation, we have already seen that transformation adds a lot of error. Then the geometry of the problem can be very irregular or twisted geometry. Scale of the problem. Sometimes I get surprised that people are using FEA for picometer or nanometer. Where is the continuum then? I think we should not use this method for very, very small dimensions, because the transformation errors are going to be very high. The material properties, what your equation has assumed that material is continuous, uniform throughout. It doesn't take into account the defects in the material, discontinuity, and therefore you cannot take the results for granted without verifying, validating it. The built-in material defects, that's already covered. The boundary conditions are very, very critical, and many people do not understand the boundary condition properly. There could be a boundary which you feel that it's fixed, but it's not fixed actually. It's flexible. The appropriateness of the mesh you have created, whether it is good enough for that purpose or not. For example, people create triangular mesh. Triangular elements are supposed to be adding extra stiffness in the structure. Everyone knows that. It's called stiff elements. So one should avoid using triangular elements. But nowadays people do not have time, or they don't want to work, hence everyone generating triangular element. Because triangular element will have no warpage. Why? Because 3 nodes define one plane always. 4 nodes may not define one plane. It go out of plane. But 3-dimensional, that triangular element will have no warpage. The mesh quality, we have already discussed. The post-processing, this is again going to come from the shape function, and it's going to have lot of integration, differentiation, and interpolation. For example, you get displacement, and then you find stress values. Okay, I will show you a few examples where analysis was done. I was also involved in those analyses, and what went wrong. Objective was to reduce the weight. This is a hook, and you can see here there is a lever and extended portion you can see. In this hook, a ball a spherical ball is assembled and it has got hole and then rod goes inside. This is for agri application. And then you pull it and it has to basically resist that load. But this component has failed. We have reduced the weight by what we did, we based on stress, average stresses, own misses stresses, we reduced the thickness and we found that there is no failure. But actually on test rig it has failed. Why it has failed, which we realized later on, because the deflection was large. Why deflection was large? Because you have reduced the stiffness of the hook. Once deflection is large, then the point of loading shifts towards the tip, bottom tip. You can see there, that side. If it shifts towards the tip, and which is, then it adds more bending stresses. And it further multiplies and multiplies. Hence what happens? The displacement at certain point is very high and cracked. Initiation takes place and it breaks. So we should have knowledge of not only stress but something else also. This is a very good example. I am not able to show you actual clip design. This project I did for long before. They did for Escorts Railway Division. They had Australian design they wanted to introduce in India. A lot of work was going on. They had got a special machine where you insert the strip, steel strip, and it eventually gives you clip out. So automatic machine. And this, when it was assembled, it becomes loose after some time. And obviously because it, while assembly itself, it has yielded. And lot of analysis, I did analysis, but I could not get any reason for that. And I asked for material testing. And they tested the material. They were using Australian equivalent, Indian steel, which was equivalent to Australian steel. When it was tested, what was found, it was very surprising. The Indian steel has ultimate tensile strength 1500 megapascal. And Australian steel had 2300 megapascal. So grade was equivalent, but this was the difference. I don't know what happened to project later on. This is another example where there is overhead crane, and this beam analysis was done. The German company wanted to do this weight reduction. Analysis could lead to reduction of weight by 30%, but they, when they fabricated and tested, then what was found, that deflection was 87 centimeter against 27. Why it has happened? Because we saw own misses stresses, average stresses. We did not look, we basically generally we ignore. Why we ignore? Because if you do FEA analysis, there is going to be a lot of stress concentration. Those stress concentration for our convenience, we ignore, we say that it's a spurious notes, spurious results, and we ignore. So we have also ignored, and the top of the beam, there was high compressive stress, and because of that, there was local buckling, and hence whole system has yielded, and it has failed. So I'm just showing you the results where we did FEA analysis and everything was right, but eventually things did not work. This is very recent project this a cycle manufacturer, very big bicycle manufacturer, was trying to implement this bracket. This is aluminum bracket, and he spent about 2.5 years to do indigenization of this Chinese bracket, and they could never succeed. So I got a call from one gentleman, and he told that, can you do some investigation? I told, yes, I have got time, I can do it, but I am not sure that you will get solution. And actually there was no solution. Then I did analysis, but I asked him to give me the material property of the Chinese aluminum alloy, and then the equivalent alloy he was using here. He has actually tried many alloys. So what was found that aluminum has got very small elongation in their catalog, but Chinese aluminum had 7% elongation. And what was happening? If you see the problem, this is basically a contact problem. And if elongation is not large, and if you are clamping it, then what will happen? Material will not flow, and there will be, momentarily, there will be very high stresses at certain points. And hence, the bracket will yield at that point, and its spring property will disappear. This was what happening. Once they assemble, the bracket becomes useless. So I did analysis, presented results. He told that yes, these results are okay, but I mean results were of no use that time. So I asked him to use the grade. I told him that you show me the catalog and I will suggest you material. I am not a material person, but that's my hunch or intuition. I suggested a material with high elongation. That material was implemented, and the project was successful, and it is implemented now. So my point here is that we do FE analysis, but we keep our eyes open. Thank you very much for listening me without much content in the lecture. Thank you very much. हाँ ये हटा देता हूँ, इसकी अब ज़रूरत नहीं है, हटा देना। मेरा एक स्टूडेंट FE पे काम कर रहा है, और उसने जब शुरू किया हमने बोला बहुत डिफ़िकल्ट टॉपिक ले लिया है, तुम बहुत परेशान हो जाएगा, लेकिन वो माना नहीं, और ही इज़ स्ट्रगलिंग एक्चुअली। तो अब क्या करना है, इसको हटा दें।
करना इसका
कर दो,
इसका स्क्रीन कर दो।
Thank you, Professor H. Singh, for his elaborative talk on the implementation of the finite element method in displacement problem and also presenting some gaps in the theoretical and practical aspects of FEM. Now I would like to request Professor D.K. Singh, HOD, Department of Mechanical Engineering, to facilitate the Professor H. Singh with a sapling. So with this, we have completed the first day of our industrial training. Thank you for attending it. Tomorrow we will be having the session from the Ansys ARC Info Solution in room number 141, 6th block. It will be at 9:30.